With the permission of all dignitaries, I wish to begin the session. Greeting to everyone present here. I, Ms. Shilpi Bhuiya, welcome you all to an informative one-day international faculty development program on evolution of the construction industry, but to address infrastructure challenges, organized by Department of First Year Engineering and Civil Engineering, AISSMS, College of Engineering, Pune, in collaboration with Superior Construction USA and on behalf of the entire organizing team, I would like to express my deep gratitude to Mataji Rajesh and other dignified members of AISSM Society for their encouragement to conduct this International Faculty Development Program. I wholeheartedly welcome the speaker for today, Mr. Josh Tisner, Controls Manager, Superior Construction, Indiana, USA, Mr. Tejas Borse, Project Controls Engineer, Superior Construction, Indiana, USA, Engineer Hemant Jain, Regional Head, Technical Services, UltraTech Cement Limited, Pune Region, the Principal, Dr. D.S. Bormane, HOD, First Year Engineering, Professor V.R. Patil, HOD Civil Engineering, Dr. U.R. Awari, Convener Mr. Harsh Shah, Technical Services, UltraTech Cement Limited, coordinators of this event, Professor Preeti Satarkar and Professor Merlin De Cruz, all are wonderful participants. The vision of our institute, service to society through quality education, we have organized this one-day international faculty development program. Without much delay, I now invite our principal, Dr. D.S. Bormane, to kindly present the keynote address. Over to you, sir.
Thank you, Shilpi Madam. Good afternoon, everyone. Personally, on behalf of AISSMS College of Engineering, I welcome Mr. Josh Krishnar, Control Manager, Superior Mr. Tejas Borse, Project Control Engineer, Superior Constructions, Indiana. You're happy it's alumni of AISSMS COE, Civil, and Mr. Engineer Hemant Jain, who is the Regional Head, Technical Services, UltraTech Cement Limited, Pune region. I also welcome all the participants on this occasion of one-day faculty development program on evaluation of construction industry to address infrastructure challenges. I just want to mention about my society and college. This AISSMS Society, All India Sri Shivaji Memorial Society, is established way back in 1917 by His Highness Excellence Srimant Shahu Chhatrapati Maharaj of Kolhapur. And this our institute AISSMSU is started way back in 1992. We are running 8 UG programs, namely chemical engineering, civil engineering, computer engineering, electrical, electronics, telecommunication, mechanical. We have 2 special programs, that is mechanical sandwich and production sandwich. Speciality of this program is the students are getting opportunity to work in the industry for 1 year. They are in the industry out of this 4-year degree program. So they are getting good opportunity to have practical exposure and they're well acquainted with the this industry environment. We have PG programs, 7 PG programs, and civil specialization. In mechanical, there are 2 specialization: design engineering and automotive engineering. Electrical engineering, running line, and ENTCs, VLS and embedded, computer engineering and chemical engineering. We have 2 research programs also. I'm very happy to share all of you that because of strong support of our Honorary Secretary Sri Malloji Chhatrapati and other society members and their continuous support and encouragement to all the faculty and staff members. And students are doing fantastic as far as the academics is concerned. If you just see the list of Savitri Phule Pune University, so you find every year there are more than 20 rankers, and that shows the quality of education. And in last 5 years, more than 150 plus rankers produced by our college. As far as the teaching learning process is concerned, along with the regular process, we are encouraging and providing the platform for the students to showcase their skills and potential. And we have various student clubs, student associations, student chapters under which students are doing fantastic. Unfortunately, because of this pandemic situations, there are limitation on this practical exposure for the students through these various platforms. And that's why we are conducting the various activities like today's webinar. Every department is coordinating at least one activity in every week for different. We're inviting various experts from various domains for the students and faculty members. And this because of these various activities and support to the students, college has achieved many achievements in last few years. Our college is accredited by NAC with A plus grade, and at that time, ours was the first college to get this A plus in the new format, and it is because of the strong support of the management, participation of the faculty, staff members, and student contribution. Especially our college is famous for extracurricular and co-curricular activities. We have various clubs like Baha, Supra, EP Cycle, Garuda, Drone Club, Robo Club. Computer department is having Codiometric Club. Then chemical is having various. These clubs are really what nowadays is required. Learn by doing or learning by doing that way they are getting opportunities, and because of these students are showcasing, and I'm very happy to share on this occasion few students are they have started their own startups, and one of the group of students they have established the company also. That student is now in final year, so before completion of graduation he started giving opportunity to others to work on his project, so others are also participant. That shows the commitment and contribution of everyone. Once again, I congratulate Dr. Avari and VR Patil and our team members for coordinating this activity and giving the opportunity to learn many more things from these experts in this particular field. So once again, I congratulate and welcome all the experts, today's experts, and I'll appeal all the participants get the benefit of this particular activity. Thank you.
Thank you, sir. I now request the head of first year engineering department, Professor VR Patil, to address the audience with the objective of organizing this international faculty development program. Over to you, sir. VR Patil, sir.
So you're mute, please. Can you unmute from your side? Yeah.
Yeah. Am I audible now?
Yes, sir. You're audible.
Yeah. Good afternoon, all. All eminent speakers of today's International Faculty Development Program. On behalf of First Year Engineering Department, I welcome all the participants. Now the title is Evolution of Construction Industry to Address Infrastructure Challenges. And for this specific faculty development program, today we are having the speakers, Mr. Josh Isner, Control Manager, Superior Construction, Hemant Jain, sir, who is the Regional Head, Technical Services UltraTech Cement Limited. The Tejas Borse is a Project Control Manager from Superior Construction. I will say proudly say he is our alumni. Actually, the civil engineering, oldest branch of engineering, and I think formal education started about 150 years back. And the role of civil engineer has increased many-fold as it is encompasses various specializations. To enhance the knowledge in a particular domain, short-term courses or FDP are found to be very useful. And objective of today's FDP is to facilitate and enhance the technical know-how, practical applicability, and to provide opportunities to interact with international field experts in construction on a single platform for faculty, industry personnel, and the budding engineers. Actually, on this occasion, I will say that knowledge will get shared to improve the learning of each and every faculty members as well as budding engineers. On this occasion, I want to appreciate the convener of the program, Shilpi Bunyan Madam, Dikruz Madam, and Satarkar Madam. Within a very short period of time, they have arranged this faculty development program, which is of international level, which is and for which we are getting very much good response. Just for the knowledge of all, I will share. We are getting the participants from the India as well as from the abroad. We are having participants from USA, UK, Canada, UAE, and Australia. In percent, I will say right now, 45% of faculties are attending the program. Students are 46%. Industrial personnel are about 7%, and 2 to 3% other members are attending and enjoying this program. Without wasting much time, I welcome all the eminent speakers for the today's FDP. I will hand over to the madam.
Thank you, sir. I know engineering department, Dr. U.R. Avari, to enlighten the audience about our civil engineering department. Over to you, sir.
Okay, thank you, madam. May I audible?
Yes, sir.
Okay. Good afternoon to all. Hi, Dr. Uttam Avari, Head of Civil Engineering Department of AISSMS College of Engineering. Welcome to today's resource person and participant for the one-day International Faculty Development Program on evaluation of construction industry to address the infrastructure challenges. In short, I will brief the departments. Department of Civil Engineering was established in 2002 with the intake of 16. The goal of the department is to prepare the student for successful career in construction industry that meets the need of Indian as well as the multinational companies and to excel in higher studies. The department has experience and dedicated factors, strong commitment for the engineering education and professional ethics. In academic year 2011-12, as per the requirement, we introduced the PG course in structural engineering with the intake of 18. And in the next year, 2012-13, again as per the requirement of the civil engineers, we increase the intake capacity from 60 to 120. Some highlight of the departments are the department have the well-equipment laboratories with the advanced instrument, innovative teaching learning methodologies, computer center with the recent software, center for the competitive exams, student chapter. At present we have the two student chapter, Institute of Engineers and the Indian Green Building Council. Then department arrange the internship for the students. Besides that, the department arrange the monthly presentation for the seminar and project. Again, the department arrange the skill and technical skill training for the student to improve the placement activities. Department arrange the expert lecture from the industry person and arrange the industrial visit. During the COVID-19, around the 1 year span, the Department of Civil Engineering organized the 5 FDP and 11 webinar on the different topic of the civil engineering, and we are taking the advantage to provide the knowledge from the expert from the industry to our student as well as the society. Okay, thank you. Over to Shilpi Madam.
Thank you, sir. I now request Engineer Hemant Jain, sir, Regional Head Technical Services, UltraTech Cement Limited, Pune region, to enlighten the audience about his company, UltraTech Cement Limited.
Yeah. Good afternoon, all the participants. Good afternoon, principal, HOD, faculty member, speaker of the DA, and all the students and all the guests across the globe for today's one-day faculty development program named evolution of construction industry to address infrastructure changes. As far as I am concerned and today's subject is concerned, very indeed needed, because a lot of changes as far as this today's scenario is concerned. Even in cement, various varieties from OPC 33, 43, 53 to PPC to SRC, PSC, so many varieties, so many grade, and so many things are happening, not only in cement particularly, but in concrete also. So being the fundamental material of the construction industry, whether it is a cement or the ultimate or the final product is concrete, it is a paramount importance to understand this material, non just as a textbook or a material of 5 or 4 or 6 ingredient, but in a detail, in depth. So I will be very much happy to enlighten all the gathering during my presentation. So how the industry is moving and where it will reach, where whether there is any substitute for cement or concrete. If no, what is the answer? And if yes, how to go about it? So that will be covered during my entire presentation. But I am happy that AISSMS college is organizing this wonderful one-day faculty development program, and I wish all the best for today's program. That today's program will be a grand success and will remain one of the remembered program to the faculty and to the students across the globe. Thank you, ma'am.
Thank you, sir. I now request DeCruz madam to introduce Mr. Josh Kissner. Over to you, ma'am. DeCruz ma'am.
Yes. Am I audible?
Yes, ma'am.
Thank you. I, Mrs. Marilyn DeCruz, welcome you all to the first session of this International Faculty Development Program. I wholeheartedly welcome the speaker for this session, Mr. Josh Kissner, who will be guiding us on the topic Infrastructure Construction. Mr. Josh has completed his Bachelor of Science in Building Construction Management from Purdue University. He was earlier employed with the Kuwait companies for a span of 13 years and is currently employed with Superior Construction since 2019. During his tenure of professional experience, Mr. Josh has played vivid roles in bringing to life various infrastructure projects, such as being a field engineer, estimator, environmental quality manager, quality control supervisor, general superintendent, project quality manager, etc. He currently holds the position of quality control manager and project controls manager at Superior Construction. He has been ASQ certified manager of quality, organizational excellence, AWS certified welding inspector, ACI concrete construction special inspector, ACI Field Testing Certification Level 1, American Galvanizers Association Inspector, certified with DOT Hazardous Waste Manifest. I now gladly invite Mr. Josh to enlighten our audience with his immense expertise and deep knowledge. Over to you, sir.
Thank you, ma'am. And thank you, Dr. Barmani, and Dr. Patil and Dr. Awari and Madam Shilpi for putting all this together. I couldn't have done what I've done and put the presentation together without my help from my friend and colleague Tejas Borse. So I will share my screen now. Okay. So I just wanted to explain, first of all, that I really appreciate everyone and the introductions, but I never really considered myself an expert within the market. I've just necessarily been working here for a long time and have some experience in doing what I'm doing. And mainly what I wanted to explain was that I've been a general contractor for my whole career, and I've really understood construction from the perspective of being a general contractor. And what that means is that so a little bit more into what we're going to talk about today. So we want to dive into infrastructure as a whole, right? And that includes the different types of contracts that we encounter within infrastructure in the public sector and in the private sector. And I'll explain what I mean by each of those, and then get into the different types of infrastructure construction. And this will be more of the parts and pieces that go into infrastructure projects. Obviously, in the time that we have, we're not going to dive too deep into any one area of this, but kind of give you the perspective of the general contractor. This is what we deal with from beginning of project inception all the way through the end of the projects. So for the public sector, there are many different types of agencies that we work for. And when I say public sector, I say that because that would be a government agency. And the Federal Highway Administration is the federal DOT, Federal Department of Transportation. They oversee all of the state Department of Transportations, which then can oversee the local Department of Transportations. All of those kind of roll in all of the streets, bridges, highways, all of the main thoroughfares that you use within the national level and the state level and the local level. Aside from all of that, there is the U.S. Army Corps of Engineers, and that would dictate more of the waterway type construction, dams, locks, any breakwaters, any type of construction that would happen on waterways, in rivers, in lakes, on the ocean, and whatnot. So as far as the public sector, there are many different types of contracts that we can get into within the public sector, and the most common type of contract is the unit price contract, which is a design bid build type contract. That means that the design would happen prior to the contractor getting involved and bidding on the work. And then once the contractor receives the contract, then it would build the work in a unit price fashion. What that means is that there will be bid items for each one of the different areas of construction, and you would install the quantities for those bid items. And then if you go over those quantities, the client would give you a change order. And if you run under those quantities, then the client would save money in the fact that you didn't build as much as they thought you were going to build. All of that kind of wraps up into the fact that the client holds the contracts with the designer and also the contractor. So the client is really the leader, the one that is setting the tone or the schedule for the project, and kind of pulling along the designer and the contractor at the same time. So they're really controlling the whole process in that type of contract delivery. Also, there's design build, where this kind of turns that around a little bit. And this is what I was explaining a little bit earlier, was that in that the design build world, which is becoming ever more present, is the fact that the client will go to the contractor or a contracting team, which the contractor could then team with a designer in order to build the project, and they're really the leader of the project. That means that the contractor then controls the whole process from beginning to end of the design build type contract. It's a very popular method, and it helps because it allows the client to use less staff on their portion to have to control the project. When they give up some control to the contractor and they rely on the contractor in order to kind of lead the project, that means that they can reduce their overhead and they don't have to carry as many people to get a larger scale project done. like I said, that lends to the client then having to give up some control. And that's where we're kind of running into a little bit of friction within the industry because of the fact that they're not as in control as they would typically be. So what happens with those types of contracts is they then do a much more thorough look at who they're giving the contract to. Typically, they'll go through qualifications phase prior to issuing the request for proposals for these type projects so that they can understand the experience that the contractor brings to the table and understand what they can provide to the situation in order to make those contracts successful. And at the end of the day, that's really what everyone's working towards is you need a successful client, you need a successful contractor, and you need a successful engineer to say that you've had a successful project. And then also in the same note, there is engineer procure construct, or EPC. It's a type of contract that is similar to design build in the sense that the design and the construction are both under the same contract. But typically an EPC contract, the difference between a design build and an EPC is that the design build, the contractor would typically be the leader of the project. And in the EPC world, that's more of an engineering firm. And the reason that is because with EPC, and these are more energy projects than they are infrastructure projects, but when you have to engineer and then procure all of the equipment, that typically the dollar amount for the engineering and the procurement are typically more than what the construction would be on the back end of that. So the leader of the project then shifts from the contractor over to the designer or the engineer, and they would carry the engineering and the procurement portion of the project, and then they would team with the contractor in order to get the project completed. So now, aside from the public sector, there's also the private sector. And speaking more directly towards infrastructure type projects, in the private sector, the main most prevalent type of industry there is railroad. And within the U.S., the railroad had come along prior to the automobile, and that was the main source of moving goods around the country was building railroads. And all of those railroads were built by entrepreneurs around the early 1900s. And again, at the time, it was very rudimentary technology in order to build this type of infrastructure. A lot of that infrastructure is still the same from when they built it in the early 1900s to today. So that means that this infrastructure is also extremely compromised and needs to be replaced. So now that we understand design better, we're going into these types of situations where we are building a better product and it has a longer design life. But again, to anticipate a 100-year design life is unfeasible. So that's the main private sector for infrastructure type contracts. There are also commuter railroad, which would be typically a commuter railroad. You would share tracks or the types of tracks with freight railroads built the same way. Also, there's light rail, which would typically be in and around cities. It's a lighter type of train. That's why they call it light rail. And it's not as heavy duty of construction for those types of rails. And also airports. Airports and airline services are one of the larger types of industry or markets within the infrastructure industry. And the reason why those are now becoming even more important is a lot of these airports, again, were built 50 or 60 years ago when airplanes had first been become mainstream. and they were built with a few runways and taxiways because there wasn't a lot of air traffic. Well, now in 2021, air traffic is one of the main ways to travel around the world, and now we have to expand all of these airports in order to be efficient, and we need to reconfigure a lot of the runways and taxiways that are in these airfields. I worked in an airfield in Chicago, Illinois, where we were completely reconfiguring every runway and taxiway within the airport. It was a $13 billion project just for the concrete and pavement that we were rebuilding. But that has the implication of rebuilding runways and taxiways is that you have to consider now when you expand from a smaller footprint in those areas to a larger footprint, now you're creating hard surfaces all over a much larger footprint. And what that means is that whenever rain falls onto those surfaces, it's impenetrable. That means that there needs to be larger drainage structures, larger facilities in order to handle all of the drainage, and then a lot of chemicals are used within airfields, which means that you can't just discharge that type of water directly into waterways without polluting the waterways. And you need larger retention basins, then also wastewater treatment facilities. Is a very big ripple effect from the initial idea of reconfiguring an airport to then moving on to the downstream markets that are affected by the single type of construction project. So within the private sector, the types of contracts that are most prevalent are lump sum and cost plus type contracts. And these also would be design build or bid build type, but this is just the configuration of the types of project. Lump sum lends itself very well to design build infrastructure, energy, water and wastewater, and cost plus is the same as that as well. And then also cost plus is a very common type of project to use with engineer, procure, construct. So, okay. So within that, like I stated earlier, the highways, roads, and streets built about 60 to 75 years ago, we're rebuilding those facilities now. A lot of times within even concrete and asphalt type construction on roads and bridges, we do a lot of resurfacing, and as you get into removing a lot of the older type of construction, you'll see where the technology, we didn't understand 100% why things were happening. Roads were sinking and bridges were sinking, and a lot of times the fix for that type of situation was more of just add more pavement, add more asphalt, add more concrete, and keep paving over the top of it. It's cheaper to do that than it is to tear out the entire section of roadway or bridge or whatever and rebuild it over again. They didn't understand that what that causes is a situation where you just keep sinking, or you keep the infrastructure keeps falling apart underneath what you're doing. Really, to build that correctly, you have to remove everything down to a solid surface and then start from the bottom and work your way up. And I'm a firm believer that if you are building your section well and the correct way to build it, you're going to be solid from your solid base through each layer of your construction section, and then you'll have a solid road or bridge on top, and it won't fall apart. And we'll get into what that section looks like further into the discussion. So bridges are mainly dependent upon the type of parts and pieces that go into them. So steel or concrete or whatnot. Well, it's really dependent upon the life of those types of materials that go into the construction. So looking back at the bridges that were built 100 years ago or 75 years ago, the coating on the steel wasn't really understood how that was going to protect the steel. What we're seeing now in a lot of the bridges that we're rebuilding is the fact that we have a lot of section loss, and section loss means when it's specified that you need to have half-inch steel plate or 3/4 inch steel plate. We're inspecting these bridges now, and we're looking, and what used to be a 3/4 inch steel plate is now only a half-inch or 3/8 of an inch thick in some spots. And in those spots, if they're in critical areas within the beams or other parts of the bridge, it could cause collapse of the infrastructure. So we're focusing on the most degraded infrastructure first, obviously, and we're going to be rebuilding a lot of this stuff that has been built 75 or 100 years ago. Funding for this type of work, the highways, roads, streets, bridges, has historically always been low. Within politics, it's hard for politicians to say that they need to spend the money on the infrastructure in order to bring everything up to current standards, because there is no direct correlation to anything coming back to someone for actually spending that money. So there's no, it's an investment that they don't see an immediate reward for. It's more of an investment within the country, an investment within the world in order to put money back into the economy, and it's needed, obviously, for everyone to be able to safely commute around the world. So what that has lent itself to has been, like I was saying earlier, about putting more Band-Aid type construction where you're really looking at patching or resurfacing or paving over instead of tearing down and building new. And obviously we understand from our perspective that that is the most beneficial type of construction that you can do because it will last the longest. So mass transit and airports, like I was saying earlier, the airports all need to be reconfigured at this point. As we're expanding the airports, the runways and taxiways need to be reconfigured in order to be more efficient. And they're doing a lot of major rebuilding projects within the airline industry. So there's a lot of that going on around the world, and larger scale projects, lots of quantity of material for a lot of those projects, and typically, like I was saying before, those lend themselves to large design build type projects, more complex construction that's needed for that type of project. So water supply is more of underground utilities, water towers, water tanks, pipe, water supply pipe, upward of 10 to 15 foot pipe, or even larger than that in some tunnel type situations. Going into New York City, there's a 25-foot tunnel that they're replacing their aqueduct with. It's 75 miles long, going from upstate New York into New York City in order to resupply New York City with a new supply of fresh water. And it's been identified that because of the old aqueduct that they built over 100 years ago, if they hadn't replaced that aqueduct, that they'd run out of fresh water in New York City in the next, I wanted to say it was within 20 years, they would run out of fresh water in New York City. So it's large scale type projects like that that are very important around the world, as we understand more about water supply and water treatment and whatnot. Speaking of that, getting into wastewater treatment. This is a not exactly infrastructure type construction, but it is sister to infrastructure in the fact that the majority of the construction for wastewater treatment facilities is concrete tanks, concrete baths, lots of equipment that's involved in that, and many utilities that are involved as well, and whatnot. So it's kind of a sister industry to the infrastructure. And also one of the main markets that's been popular lately has been in many major cities. They used what's called combined sewers, and that means that they originally combined the sewer pipes with stormwater pipes within the city in order to control both of them in the same utilities. They were saving money. They were saving time in their infrastructure and building of the cities. What they didn't understand was that these types of facilities can then be overrun when you have large scale storms, a lot of precipitation. Then these combined sewers then will fill. They'll start backing up into the streets and into houses and buildings and basements of buildings. So what they did in order to combat that was they had overflow areas where those sewers would then overflow into the lakes and rivers and whatnot, streams that are around those types of cities. We didn't understand at the time, again, the technology wasn't there to understand that was then polluting all of our waterways, our main waterways around our cities. And now that we're more advanced as a society, we've started taking and putting those combined sewers into larger scale type projects, building tunnels underneath cities, building large containment areas adjacent to cities, and then taking those combined sewers and tying them into these large storage facilities that then can handle more types of, more quantity of precipitation, so that it doesn't just overflow into the water supply that's around the city that we then use for drinking water and whatnot. Keeping those two separate was the main goal of these types of projects. And then also power generation and transmission. This is more in the power or energy market than in infrastructure, but it's worth the mention because of the ever-growing trend of global warming and combating global warming, as power generation is one of the easiest to address within that realm in order to lower CO2 emissions. And that's kind of brought up the market within the world so that people understand, we can use cleaner energy in order to reduce our CO2 emissions. And that's really spawned a large market around the world in order to clean up a lot of the power plants and go from coal burning power plants, which was historically the type of power plant that we would use, over to a cleaner burning, or even to add facilities onto those coal burning power plants in order to lower the emissions within those individual plants. And that over the last 15 years, that market has really emerged as the leading market within the U.S. at least, as we see more people doing studies on emissions and adding further facilities into the current plants so that we can control the CO2 emissions. Then getting further into technology with the telecommunications industry, somewhere around roughly around 2000, there was a major push to move from copper type telecommunication wires over to fiber type communication wires, and that meant that a lot of the infrastructure that was currently in the world then kind of transferred over to this new infrastructure. Well, you couldn't necessarily use all the what was current, so had to replace a lot of it. That's new duct banks, new transmission towers, a lot of new equipment, and a lot of new infrastructure installed for all of that. And then hazardous waste and removal. Again, there was a new budding market within the U.S. at least in the late 80s, early 90s, where they developed a government act in order to really attack contamination. As we started to understand what contamination was doing to people's health, they really focused on areas of heavy contamination and where people were getting sick, and established what they fund program in order to fund projects to remove the hazardous or contaminated waste and remove the threat to people's health and put those into areas where it can be contained. It's very prevalent in a lot of the major cities around the world. Contamination is a major issue within construction. It's hard to quantify because you really don't know what you're going to get into until you start excavating and removing the material. At that point, when you're doing that, you can then test the material to find out what is included in it, and determine at that point what you need to do in order to put it in its final resting place. Okay, so that's kind of the markets and the types of contracts, and the a little bit about the industries themselves. What I want to get into now is the main components within infrastructure construction. One of the things that we don't address here is asphalt. It kind of falls under the earthwork and aggregates section a little bit because it's not necessarily concrete, but it would be a fifth section that we could get into. But asphalt is another conversation all in itself that we could get into for hours. So these are the four main types of construction that we're going to focus on from here going forward. So within the four main types, the first one we'll talk about is foundations. And foundations include deep foundations, shallow foundations, and then the different types of each one of those. We'll cover a few of each of those. So starting with H-piles. So H-piles are typically driven pile. There are times where this could be a drilled pile that's set inside of a drilled shaft, and then concrete is placed. But typically for bearing type H-piles, they're driven into the ground, and they're typically not used for skin friction. They're typically bearing type piles, end bearing type piles. So the weight and the bearing of the top of the pile down to embed the pile. Typically, H-pile you would go down to some type of rock and bear on rock, typically for H-pile. Within Indiana, where Tejas and I are working, we have a lot of steel pipe pile, and pipe pile. The reason why that is because for the geotechnical situation that we're in Indiana, the bedrock is extremely low, and you can have hundreds of feet of a pile in order to get to bedrock. So what we typically use here more frequently is a skin friction type of pile. So a pipe pile offers a lot more skin friction than an H-pile would, and you can also add end plates to the pipe pile. so that you can add more bearing capacity onto the bottom of the pipe pile. If you hit a more dense layer underneath where you're driving the pile, then you can utilize that bearing and the skin friction as well in order to add more capacity onto your pile. Drive methods here include impact hammer. Less frequently you would use vibratory hammer, but mainly would be impact type hammers to drive the pile into the ground. Types of pipe piles include spiral welded pile. That means that the material is formed into a spiral so that you can put a spiral weld around that pipe. It's different than a rolled and welded or ERW pile, where in the fact that these other types of piles have a longitudinal weld along the entire pile. So it just gives a different type of section to the pile itself. So spiral pile lend themselves to longer piles or longer and large diameter pieces. The rolled and welded piles are larger diameter, typically shorter in length, and it's made of plate steel. So the plate steel typically can be a much thicker material and stronger, but as I said, it typically is a shorter type of pile, but it can be large diameter. The ERW is a mechanical means made of coil steel, and this is an extremely efficient and less expensive way to make pile, and it is less than 24 inches in diameter. And it, as I said, it's an extremely efficient, fast way to produce the pile itself. Further into piles, there's also helical piles, and helical piles they typically call screw piles or helical piles, and it's an extremely common type of foundation where the construction method is very low technology. As you can see in the picture, there's an attachment that can go on to basically any excavator that is a drive head for these types of helical piles, and they screw into the ground. That's why they call them screw piles. It's not an augered type pile. There is no ground loss within those types of pile. There's a lot more variation in this type of pile, so you don't see these used for very heavy bearing type situations. These are more for lighter loads, smaller structures. As you can see in the picture there, that looks like it's supporting some sort of transmission tower for power lines or something along those lines. So it's not as heavy as a load as a bridge component itself, but a foundation nonetheless. They're very easy to install. They couple together, and as I said, they kind of spin or screw into the ground. Auger cast piles. These are a less frequently used type of pile, but again, a foundation nonetheless. Typically, they're shorter foundations. They're not as heavily loaded type piles. And you would use a drill rig for this type of situation with a long flighted attachment, so that once you drill to the bottom of your pile, then you can replace the cavity with concrete. Let's see if the video here will play. As you can see, it's displacing the earth with the auger and getting down to a harder pan soil. And then placing the rebar cage. And you would subsequently fill that with concrete prior to putting the building on it. I hope that was obvious. So, They're more appropriate, like I said, for shorter type of foundations. They rely heavily on skin friction because of the auger type hole that's in the ground. There's a lot of variation in the edges of that pile, and it lends itself to very high skin friction within those piles. One type of foundation that is becoming ever more popular is they're called micropiles, and this is very popular because of the type of situation where you could have low headroom or a very, very difficult access to get into where you need to drill these piles. The reason why you're able to utilize this type of foundation for those types of situations is because the equipment that you're using in order to drill these piles is a lot smaller, easier to get into tighter access types of situations. These piles typically are extremely deep. They typically are drilled down to very dense type material, driven deep into bedrock. And what you would do is you would displace your material that you're drilling through and advance a casing while you're drilling into the ground. So every specified increment where you need to advance the casing 5 foot or 10 foot or something along those lines, you would advance the drill head and then follow with the casing, then advance the drill head and then follow with the casing. Once you've gotten to the depth that's prescribed by the engineering, then you would install a rod. Typically, that rod would be carrying all of the bearing weight off of the structure that's built on top of the piles, and subsequently fill the casing and around all the rod that you would install. You'd pump grout into that in order to solidify the type of foundation that you have. Again, like I said, this typically be used for low overhead situations or hard to access areas and whatnot. So the last type of foundation that we wanted to go through was caissons. Caissons are a very popular or well used type of foundation. This can be a prefabricated structure that would be brought out into a waterway type of situation where you would then sink the caisson into the excavated area, or you would just sink it through the mud line of a typical bridge type situation, so that you're on very solid ground underneath it. After it's sunk or it's put in place, then you would typically fill it with concrete, and the concrete would transfer the bearing from the bridge or structure that's on top of it to the better bearing soil or rock that's below it. All right, so that's a little bit about foundations. Now we'll get into steel. And steel here, we wanted to focus on bridge steel because of the fact that that lends itself to the infrastructure industry specifically. So a lot of different types of steel used in infrastructure, and we'll touch on a few of the different types. The first type, the most commonly used type of steel within the infrastructure industry, is steel beams, and typically they're used for bridge construction. So the beams would bear on the concrete construction that's below it. Typically, it's concrete construction that's below bridge beams. You've got the foundations that we just talked about. Then on top of foundations, you would have concrete piers or walls that would support pier caps or abutments. And then you also have the columns in the substructure, and the beams would sit on top of that substructure. The beams would span from pier to pier, which would be the substructure that we just talked about. And then the deck would sit on top of the beams. And obviously cars sit on top of the decks. So, or people for that matter. But the different types of steel beams, this one in particular is plate girders. And a lot of times plate girders are used for long sections or short sections for that matter. But the reason why plate girders are typically used is when you have a heavier load that you need to transfer from the deck down to the substructure, because you can use very thick plate steel in order to build these beams. And what it is the web that's in the middle there can be upwards of 1 inch or 2 inch, all the way down to 1/2 inch or 3/4 inch. Obviously, the longer the span, the heavier the girder is going to be, and it's a welded type construction. And it could either be mechanical means of welding or people welding those plates together. They're fit up and welded in a shop type situation, not as opposed to in the field, and it's more controlled area and more controlled environment in order to make those welds. Those welds on those plate girders are the critical portion of the beam themselves. If the welds are not performed correctly, then it can have a catastrophic effect on the beams. Next is rolled sections. So a rolled section means that it's formed by a rolling machine in a mill, and it can be either hot rolled or cold rolled. And what they do in the steel mills is they will produce lengths of these types of beams and ship them to a fabricator in order for the fabricator to then add all of the additional steel that is used to support that rolled section. Most common is a W section. When I say W section, I mean, for example, W14 by 112. The 14 would be a dimensional portion of the beam, and the 112 would be the weight of that beam. These are the ones that are shown in the upper right corner that I'm talking about right there. And also something like W36 by 226. So you can have these on rolled sections are typical for shorter spans. The larger type beams, when we're speaking in respect to steel, are more plate girders or tub girders. We'll talk about tub girders in a minute. But the rolled sections are usually used for simple spans and shorter type spans. All of the sections that I mentioned here are per the American Institute of Steel Construction, or AISC. Kind of mentioned a little bit already is tub girders. Tub girders can be used for very long sections. They can span very long areas between piers. They're very expensive because of the amount of steel that's used in order to support a fairly small width of a roadway. As you can see in the one picture there, they can be paired together in order to make the construction time quicker. So if you can't close roadways down for as long as you need to in order to use a plate girder type situation, or like in this case, you have a curved area, you cut down on the number of piers that you need in order by using tub girders, but they're extremely long lead time in order to have made, and like as I already said, they're very expensive. As a whole, like this is shown here, this is an extremely large box girder that's shown on this picture, but They're lesser used because it's of extremely heavily fabrication. It's fabrication intensive, so they're extremely expensive. But they can be used for more modular type construction, as you see here. Once they finish this, there's probably some connection plates within each section of the box girder, but that should wrap up the total construction within the project. Used a lot for rail type situations or smaller bridge type situations, not as much for roadways and whatnot. As I said, can be prefabricated and sent to site. A lot of times you won't have the opportunity to be able to use this type of girder in more city type situations because of the fact that you can't ship it to the site due to restrictions on height, going under bridges or going over bridges with weight and whatnot, because these are extremely heavy and extremely large. There are different types of box girders. Obviously here we show the steel type of box girder, but also there are precast concrete box girders as well. And a lot of times what you'll do with the precast concrete box girders is you'll put a bunch of those together in a simple span type situation where you would pave the roadway over the top of that. Obviously, with this type of the construction, there's less construction time, so that is definitely an added bonus to this type of construction. A lot of times you need that in order to finish your project on time, but as I said, a lot more expensive. So each one of the individual types of beams that we just talked about will always have a bearing that sits underneath the beam. And a bearing is literally what the name implies. It is where the beam that supports the deck of the bridge bears on the substructure of the total system, and it transfers the weight of the beams down into the substructure, the pier caps, the columns or walls or abutments, and then into the footings and foundations. So there's a lot of different types of bearings, as you can see here by the different names that are listed, and it really depends on the condition that you have for what the bearing needs to do. Obviously, this one on the upper left is a bolted connection into the bottom of the beam itself, so that bearing probably handles some type of moment load that the beam is going to apply to the bearing. Sometimes you'll have situations like this one down in the bottom left where the bearing itself is not even bolted into the substructure or the superstructure. It just sits in between the two, typically because there's not a moment load that bearing has to handle. A lot of the reason why you have bearings in place is because they can be replaced. As you can see in the upper right picture here, there's a seam in between this precast section that's in here, and what can happen at that seam is you can have water that comes through the individual joints within the bridges, and what that does is it will quickly erode these bearing connections underneath the beams and on top of the substructure. And that is a critical component of the bridge, obviously. So if you need to replace these to extend the life of the bridge, that's a very common thing to happen. And it's a major point of weakness within the bridge if it's not paid attention to and inspected on a regular basis. Getting into some of the more miscellaneous types of steel that are included on bridges, there are diaphragms, and this could include cross bracing, wind bracing, lacing, and there's all sorts of different types of situations. These are mainly in place in order to handle moment on the bridges themselves, so it'll handle the overturning of those girders. They can be W sections that we talked about earlier. C channels or L shapes, T shapes, etc. There's lots of different types of bracing between the girders or beams that is necessary on most type of steel bridge type construction. More into miscellaneous types of steel. Obviously, whenever you have a longer span with steel girders, a lot of times you'll have splice plates that will splice these steel to make it a longer span with a smaller section of beam. Also, the stiffeners, like you can see in this picture as well, that will help stiffen the web section so that in order to support the flanges on the top and bottom. A lot of times you'll have connection angles. There's none shown here in this picture, but the connection angles typically are where diaphragms or the cross bracing will bolt into the webs of the beams or onto the flanges for that matter. It's worth noting that a lot of the original bridges that were built around 100 years ago didn't use bolts at the time. Technology obviously was a lot less advanced then, so they used more rivets. And we're replacing a lot of those rivets because rivets tend to corrode more than the more technologically advanced type of bolts that we use. So bolts are definitely a main portion of the steel types of construction that we use. Some of the other types of miscellaneous steel would be connection angles and stiffeners, like I said, also armor plates and so on and so forth. Some of the less critical steel on bridges would be, well, critical to the structure itself, would be handrails and bridge rails. These are two pictures of bridge rails themselves, but the difference between the two would be a handrail would be something that would control pedestrian traffic and not be as strong as a bridge rail, which would control automotive traffic. These are built to withstand a certain impact in case you'd have a crash on top of the bridge, so the vehicles wouldn't then fall over the edge of the bridge. Okay, one of the most commonly used types of steel around the world is reinforcing steel. If you were to have cracks form in your concrete, it would hold up to the corrosive nature of the elements that are exposed to the rebar, and even less susceptible to corrosion is stainless steel. It's more pure. There's less impurities within the steel itself, which lends itself to less corrosivity. Obviously, rebar is the main structural component of the concrete because of the fact that concrete is very brittle. It can break very easily. The rebar is the structural component that holds all of that concrete together. Okay, that's the main portions of steel that we wanted to talk about. Now we'll get into concrete a little bit, and I won't get as high tech into concrete as the next presentation. Hopefully you get more out of that one for the concrete itself. This is more about the types of concrete construction that we would use within the infrastructure industry. So the concrete bridge components that we'll talk about are footings. Footings typically would sit on the piles that we had discussed earlier. Then on top of the footings, you'd have an abutment or a pier. And within the piers, you'd have either stems or columns. And then on top of the stems or columns, you'd also have caps that makes up the piers. And then you have the beams that sit on top of the piers and the deck that sits on top of the beams. So for the footing, I know this one here says or pile cap. If you have pile, then it would be considered a pile cap. Sometimes you have a situation where it's just a spread footing. So the footing is literally what is bearing on the harder soil that's beneath it. And these are one of the critical components of the bridge construction itself. It's usually the thickness is dependent upon the load that's placed onto the footing itself. So the taller the bridge, the larger the bridge, the bigger the footing that needs to transfer the load from the deck down through the substructure into the footing. Typically a lower strength type of concrete. It's exposed to less elements. Typically, you would have these types of situations where they're backfilled either 100% over the top of the footing or just around the footing, but it's exposed to less elements. Typically, a lower type strength of concrete. And it's really the foundation that that your bridge would sit on. Abutments is a type of pier that would be at the end of your bridge. The abutment, the abutment in this picture here, physically sits on top of the footing. This would be the abutment wall here that transfers the load from the beams down through the bearings seats, down through the abutment into the footing. It typically will hold back embankment. In Indiana, where Tejas and I work, there's less abutment type situations, more pier cap type situations, where the pile all the way up to almost the bearing location of the beam itself, and then have a smaller cap that's on top of that, and then wrap a different type of earth retention around in order to support that the earth that's behind the abutment. Piers are the next component that we'll talk about. All of the bearing locations of all of the beams are considered piers. When you have a multiple span type of bridge situation, the piers are spaced to match what the strength of the beams are themselves, or girders. And like I said earlier, you have the footing that the pier would sit on, then the stem or the column, and then on top of the stem or column, you have the cap and the bearing seats for where the beams actually fall. In this situation specifically, obviously, this is the bearing seat here, where the bridge beam would sit on top of that. This is a back wall that's behind that would support the roadway that's on top of the beams themselves, and this is where the bearings would sit that we spoke about earlier as well. So back into the beams a little bit, the precast concrete beams kind of fit more into our concrete section than into our steel section, but it's a beam nonetheless. A lot of times use concrete beams because they are they can handle a lot longer of span than I should say a lot longer of a span in a less expensive type of situation. To span the same length between piers, as is indicated here in this picture, the beams would be much more expensive if you made these out of steel, because the section would have to be extremely large. You'd have to have extremely large plates in order to do that, or even the tub girders that we showed in the one slide. Those beams would be extremely expensive to make. In this situation, with precast beams, almost all times, these are post-tensioned, which means that you would put some sort of steel rod or strand that runs through the mold prior to placing the concrete within the mold for the beam itself. And then afterwards, you would tension those rods or strands in order to give the beam a more structurally sound section. These are typically made in precast yards, not on site, not on where the construction is being performed. They're typically sent either via truck or over waterways on barges and whatnot in order to be set in place. Okay, onto the deck. The deck is obviously the top of the bridge. Most times within concrete construction, the deck is the wearing surface that the cars would be driving on. In this situation that you can see in this picture, this is a bidwell machine that would be placing the deck. And the reason why you would be using that is because this would be the wearing surface where the cars would be driving on. This helps to create camber, and we'll talk a little bit about camber here on the next slide. But you have camber in both direction, multi-directional camber across and longitudinally with the bridge, and the bidwell itself, the machine that places the concrete, would lend to creating the cross slope that's on the bridge. So you can automatically have that already formed into your concrete. It's extremely critical to the success of the bridge. You'll see a lot of times in infrastructure that's failing, where you see a lot of patching that happens on these bridges. Once you get to a certain point with the amount of section loss that you have within the deck itself, then they end up having to completely remove and replace the deck, or even the entire bridge. As we talked about, there's camber within the bridge itself. So what that means is when the beams are set, the beams will have, this is kind of exaggerated in this situation, but more of a curvature to the beam, so that when the load is placed onto the deck with the concrete itself, then this camber here will then kind of settle out to make more of a smoother roadway. So to offer a smoother ride for vehicles that are on top. Obviously, there's areas within the bridge that have the positive camber and the negative camber at the points where the beams are bearing. That obviously is negative camber in that situation. But as the load is applied to the individual beams themselves, then obviously that'll kind of level out. Next component are approach slabs, and 50, 75, 100 years ago, approach slabs were not a technology that was understood. So a lot of times this wasn't even built. And what happens when there's not an approach slab is, as you can see in this situation here, this is a very, very good depiction of how the earth will settle out behind the abutment itself, and you'll have large bumps at the abutment location. And when that happens, then the cars or trucks or whatnot that are coming across the bridge then hit the pothole or the settled out area behind the abutment, and it's putting a load on the bridge in a direction that it's not intended on addressing. So you get premature failures of your abutments, premature failures of your beams. Then you have water that'll travel through your cracks in your abutments and then corrode your bearings and the ends of your girders and whatnot. In Indiana, there's been a very large problem with the beam ends corroding. So they've taken the abutment even one step further and encapsulated all of the ends of the beams in concrete in order to try and reduce the amount of corrosion that they see in the individual bridge components. The project that we're on, that Tejas and I are on currently, we'll be pouring one of those integral abutments, is what they call them, here in the next couple of weeks. On to the next component, into more roadway, and you'll notice that within our presentation, like I said earlier, we kind of left the asphalt off of this specifically. but it is a major component that is used for roadway construction. This one specifically is Portland cement concrete pavement, so PCC pavement or PCCP for short. And this type of construction is easier to use a slip form type machine in order to build this construction. So this is a paver, is what it places the concrete and forms this edge that you see right here on the edge of the concrete. You can use this paver type situation in the other types of concrete construction or concrete pavement construction as well. But those I'll explain a little bit more difficulty in that situation in just a minute. What happens typically in this type of situation is you set dowel bar baskets out ahead of the paver, and those are set in order to, and I say dowel bar baskets, I mean rebar that would be set at the joint and is prone to having more type of patching situations because of the fact that it's not continuously reinforced, and you open yourself up to problems that might be below the pavement in the subgrade itself. Next one would be continuously reinforced concrete pavement, or CRCP. And as I was saying earlier, as you can see in this picture, this would be a lot harder for you to use a paving machine type situation. So you can do it, but it is a lot wider of an area and more expensive to use the paver than with the PCCP itself. As you can see, it's continuously reinforced for the entire length of the area. A lot of this is used, this type of construction is used to increase design life within the project. So if you have a design life that needs to be a 50-year design life, so you're guaranteeing that your design will work for 50 years, this is the type of situation that you'll be in. It's more expensive, obviously, because there's a lot more steel that's included, but it is a situation that will give you a better quality product at the end of the day with less maintenance and less patching type of situation. You won't have to replace it as early as the PCCP itself. A lesser known type of concrete pavement would be jointed reinforced concrete pavement, or JRCP. This is kind of a cross between PCCP and continuously reinforced concrete pavement. The picture here is actually of PCCP. If it was JRCP, you would see where you have these dowel bars and the longitudinal bars and you'd have rebar in between where the joint locations are. Thus the name JRCP. It's not as frequently used. A lot of times the application for this type of pavement is just to transition from the approach slab that we talked about earlier, that's immediately adjacent to the bridge, then to JRCP, which bridges even further out from the bridge. So it takes those loads, the settlement, and it's less strong as the continuously reinforced area than just the Portland cement concrete pavement, like it's shown here, where you simply reinforce at the joints themselves. So more of a transition type of pavement. One of the main components of bridge construction are retaining walls. Obviously, you need to retain the earth along the edges of the bridge. An abutment is a type of retaining wall, but longitudinally with the roadway to transition from the elevation that's below the bridge to the elevation where the roadway is, you need to retain the earth. There's a few different, there's a lot of different types of retaining walls. We'll only talk about a couple of them here, but as pictured here is a concrete retaining wall. These ones are very expensive types of retaining walls because of the fact that you have to excavate behind in order to pour this in place and then backfill behind the retaining wall. Typically with a concrete retaining wall like this, there's a very large footing to counteract the moment of the wall, and extremely large rebar that would go from that would transition from the footing into the wall itself to counteract the force of the earth that's behind the wall. These can be very tall or very short. It's a vertical type of wall, as opposed to some of the other types of construction with retaining walls. This one can be 100% vertical. This is a very popular component in the market that Tejas and I work in. It's mechanically stabilized earth retaining walls. These are panelized retaining walls. Each one of the individual squares that are shown in this picture, the bottom of where the wall, in order to create friction, and that friction is what holds that panel in place. So there's really not any downward force that's holding these panels in place at all. They're really being held up and in place by the straps or reinforcing that are attached to the backside of those panels. And it completely relies on friction in order to hold the wall in place. A lot of times these they can be vertical or they can be staggered a little bit. Depending on the type of panel that you're using, sometimes they step back incrementally just a little bit, or they can be completely vertical. As it says in the slide here, they're relatively thin. They're all precast materials, so they're easy to make. The system itself is what really needs to be focused on, with the connections to the reinforcing and the importance of the compaction of the material that is embanked or backfilled that's behind the wall. So the structural component then becomes the backfill material that you're using, and we'll get into backfill material and aggregates here in a minute. But the effort to compact the material behind the wall is really the main structural component that needs to be focused on when building this type of wall. Okay, the last component that we're going to get into is earthwork and aggregates, and that we're going to touch on this very lightly. We could again have gone very deep into every one of these different types of components and even asphalt itself, but wanted to bring up the different types of construction that we handle within this situation. So for excavation, obviously there's a lot of different types of excavation: large excavation, mass excavation, smaller excavation for structural excavation. Within bridges itself, you would typically have smaller type of excavation. Structural excavation is what we call it. It's a slower type of work. Use excavators and trucks in order to move the dirt. This type of spread that's shown here in this picture is more of a mass excavation type of spread. This truck that's pictured here is an off-road truck. It's not street legal, so you can't take those over the roads that you're building. But you can move the dirt on site very effectively with those, because you can take heavier loads and larger loads in order to move the dirt. This piece of equipment here is a mid-sized excavator that's loading that off-road truck there. On the right is the scraper type of excavation, and these are pulled by either ag tractors or bulldozers. And what happens is they take smaller slices of the earth during the excavation type, and but it's a self-loading type of piece of equipment, so that it only takes one operator as opposed to two operators like you have in the excavator and truck type situation. And you can move the dirt very efficiently with scrapers. They can move at faster speeds, they can move longer distances, but again, this is more of a massive excavation type of spread as opposed to a smaller spread that you'd use on bridge type construction. Getting into aggregates a little bit. So this is the section of the roadway that I kind of touched on a little bit at the beginning. being the subgrade. That's the portion that you're going to excavate down to in order to start your section that will support your roadway. And this has got a wood color here, but this would typically be dirt for your subgrade. So it's a competent material. What happens is when you excavate down to that competent material, then you would perform some sort of test in order to prove that material is competent enough to build on. If it's not, then you'll remove more of the incompetent material to down to that competent layer so that you can start building up from there. This entire section is what's taken into consideration for your strength value of your road itself. A lot of times within the design build world, the client will simply specify a strength value that the entire section needs to be, and then the designers then have the capability to design whatever section they want in order to get to the strength value that is prescribed. A lot of times when that's the case, you'll have a higher strength value than normal, so that the client receives a better quality project at the end of the project. As it says here on the slide, the subgrade is a weaker material. It's what's typically in place for that you'll encounter when you excavate. Your subbase material is a more stronger material that you would be bringing in, importing into your project in order to really create the foundation above your subgrade. This typically is, like it says here, is a free draining material, so that when you get water that infiltrates your section, that water has a way of escaping out from underneath the roadway. And the reason that is because if your section then holds water underneath it, that water acts as a bond breaker between all of your material that then creates a pumping effect within your section and causes failures in your roadway. That could cause failures from your subbase all the way through your base and through your surface, whether that's asphalt or concrete. On top of the subbase, you place a base. It can be free draining or it can be a dense graded material. Typically, it's more of a dense graded material because you want to ensure that you have a very dense surface that you're then placing your pavement on. Typically, you'd look for either somewhere between 95 to 100% compaction with that material. It's some variation in between those depending on the type of roadway that you're building. And that ensures then that you have the strongest subbase and base layers that you can have prior to then putting your surface on top of that. And surface is a little bit of a misnomer here. Typically within this picture kind of depicts asphalt. Typically within asphalt you have different layers as well, a base layer, an intermediate layer, and then a surface layer to kind of build upon that same section in order to create the strongest section that you have. And the surface could also be the Portland cement concrete pavement, as we spoke about earlier, the continuously reinforced concrete pavement, or the jointed reinforced concrete pavement that we talked about. We kind of talked about backfill a little bit when we were talking about the mechanically stabilized earth retaining walls. And that's actually, as a matter of fact, that's what they're building in this picture, is a mechanically stabilized earth retaining wall. As you can see, as I talked about, the straps are reinforcing that connects to the back of the panels. That's what this guy in the bottom right here is installing, is these straps. So they'll be laid out on top of the last layer of the embankment. In fact, if you look closely, you can see the straps laid on top of the layer of backfill or embankment here, and they're placing the next layer of backfill over the top of that. So backfill or embankment is typically what happened behind the MSC walls or behind the abutments or behind the retaining walls to kind of reshape the form of the earth that was there prior to starting the excavation. This situation here specifically, you're building the vertical wall and you're backfilling where the original earth was out here back out to this type of situation. So you can take your slope that was originally there and turn that into a vertical wall, which creates more space for roadways and whatnot to be built on top or in front of those walls. That's all of the types of components of construction and the types of contracts that I had to talk about today. Thank you very much, everyone, for inviting me to speak, and thank you, everyone, for tuning in. I really appreciate the audience and really appreciate the time that I can spend with you.
Thank you so much, sir. It was such an informative presentation. We have a few curious minds with us today, and they have a few questions for you. Could I read them out for you?
Sure.
Yeah. So Atharva Ganesh Soigonkar asks, as development and infrastructure increases the value of the land, then does the value of land increase if flyover or bridge is made, and why?
That's a good question. That kind of to more of real estate and whatnot. It's a little bit outside of the realm of our expertise, but I would say as you increase the levels of infrastructure, you're going to increase the ability to move around the area that you're currently in. So it would typically lend to more construction, more buildings, more bigger cities and whatnot. So I would say that as infrastructure is implemented, then yes, just from a logical standpoint, it would increase the value of the land that's around the infrastructure, I would say. But I'm not a real estate specialist, but I would say that it's probably true.
Thank you, sir. We have Shantanu Sanas asking us, the concept of privatization, which is originated from Britain, has started to take over the entire world. Privatization of infrastructural assets of country, example, railways, airports, etc., is really a good initiative. Should such assets cause more stress on pockets of middle, low-earning community? So why is it necessary? What is your comment on it?
The privatization of the infrastructure that I've seen in my career has been mainly around larger type of cities and larger types of societies. And the reason why that's done is because it affords the different authorities the ability to pay for that type of infrastructure. So because it's necessary, but it's not, and they don't have to come up with the initial investment. One of the things that I did not touch on, and I have notes in here, is that type of privatization of those the infrastructure. That type of contract's called a public-private agreement, or a P3 type of agreement, and that introduces a financial aspect of the project. So now instead of the individual authority coming up with the funding for the project itself, they're having outside funding come in, so that now it is even taking a further step back from the construction itself. The only reason that you're going to get funding from a private firm for an infrastructure project is by them having a guaranteed return on their investment. And the only way that you're going to get a guaranteed return on their investment is by privatizing that type of infrastructure. So that means introducing tolls into the bridges that you're building, introducing tolls onto the road that you're building, and you can guarantee that there's a revenue stream post construction that will then offer a return on investment to the financial firm that's supporting the project from the beginning. It's a very increasing. It's increasing in popularity around the world, like you said. It's used more for mega project type construction that's cost north of $1 billion in the U.S. Tejas said, what does 1 billion translate to?
That's.
Thank you. So I'm sure Shantanu has got his answer.
Okay.
So the next question is, in an infrastructure project.
It's probably not it isn't specific to infrastructure, but it's dealing with people and bringing people together to work as a team in all construction industries. You have a client that is looking to attain their #1 goals within a project, a contractor and engineers that are looking to attain their #1 goals in the project, and really leading everyone through the project and bringing them all to realize and be successful within their goals. I think that's the #1. It's not an issue. It's not a problem. It's 50-year or 75-year design lives on these types of infrastructure projects. And that's where it lends to the stainless steel rebar that we were talking about. There's all sorts of new innovative types of coatings for steel that we're using, including weathering steel, where the rust that's on the steel is the coating itself. Really protecting the individual types or components that go into the infrastructure. The bearings themselves are becoming even more innovative. The types of concrete that we're using, I'm sure the next presenter will get into concrete a lot more, but it's all, we're understanding where the failures are within the different components, and we're addressing each one of those failures in those different types of markets. So steel, concrete, asphalt, all the different types of components that go into construction, and addressing those failures individually.
Thank you, sir. We have Adhiraj Kotwal asking, as automation is widely being used in the mechanical industry, which has increased the efficiency of production while significantly reducing the cost of production, how do you see automation being used in construction field in the future? So,
automation is an extremely interesting portion of construction in general. There's lines of equipment that are now coming out that are very popular around the world of automated equipment. So automated earth moving equipment, automated compaction equipment, where you can have operators that would sit then in a room that's somewhere not on site, a very more controlled environment, much safer in order to work that way. So your machines are then run by the automated a component of the machine. Then those people are off site in order to be more efficient and safer. It's an extremely interesting component. It's not very widely used in our market, but it's coming in the very near future, and we open it with, or we welcome it with open arms, definitely. So.
Thank you, sir. We have a student with us who would like to ask you a question. Can we please unmute him, Vedant?
Sure. Yeah. Yeah, Ashutosh, please can you unmute yourself?
Yes. So first of all, thank you for such a wonderful and informative session. I would like to ask you a question. That is, actually I have two questions. The first one is like, how can we make the infrastructure sector more environment friendly? Because what I feel is it is great, but still it can be more environment efficient and sustainable. And secondly, are there any alternatives to concrete and steel? Because these, like till now, we don't have any alternatives, but what is the future? Like, can there be more greener materials? Thank you.
I'm pretty sure our next presenter might be able to speak more about greener materials within concrete specifically. I know that is a very popular movement within the concrete industry, is to move to a greener material, less carbon footprint type material. as of right now, the concrete and steel are the main components of infrastructure type of construction. I know that we're working more towards recycled materials that go into that type of those materials specifically. Asphalt itself is now incorporating more recycled asphalt to put into new asphalt in order to then even further reduce the carbon footprint. Within steel industry, it's very difficult to say that we'll revolutionize steel to the point where we can reduce that carbon footprint as well. I wish I had more answers for you on those innovations themselves. But as I was explaining earlier, I'm more of an expert on the general contractor side of things than necessarily in any one individual portion of the industry itself.
Okay, sir. Thank you. And sir, also I would like to ask, what is the future of traffic engineers, like the students who will go on to pursue their masters in transportation or traffic, etc.?
That's a good question. And as infrastructure has evolved over the last 3 or 4 decades, the amount of vehicles on the roads has become would never have been imagined when the infrastructure was originally designed. Now we have to focus on traffic patterns more than we have to focus on the actual size of the infrastructure itself, because what's happening is these roads are way overcrowded, and it lends to more backups within traffic. I think the what's going to revolutionize that type of the infrastructure world is by looking at the efficiency of the traffic itself and how the traffic moves around the individual areas. When you get into major cities like Boston or New York, the traffic is really what controls the infrastructure itself. The different intersections and through the different areas is really what's going to be a huge push here in the future to make it safer for the traveling public in order to get through those areas. I think that's a main focus, at least that is on our project specifically in Indiana, is to make the experience for the traveling public even that more safe.
Thank you so much, sir. We have next question. Seeing all the recent conditions of the global climate change and extinction level threats, can the infrastructure we create help us in survival of the extreme conditions and helping the process, making it better?
Oh, that question kind of goes a little bit beyond my realm of expertise, to be honest. I'm not sure how I could answer that question. I think that again, from like I spoke of with the last question, safety has been the main focus on a lot of these types of projects, being safer for people in the future, less accidents. I mean, automobile accidents are one of the major sources of death within the U.S. at least. So creating a safer environment is helping make that easier for everyone in the future. I guess I'm not sure if I can get any further into that one. That one's a very involved question there.
Thank you so much, sir, and thank you so much for being with us today. I now request Merlin ma'am to take over.
Thank you very much. It was a pleasure.
Thank you, Vaishnavi, for leading the question answer session. Mr. Josh, we are extremely grateful to you for such an excellent presentation, for illuminating us with so much information, and also for addressing the questions of our audience. I now invite Shilpi ma'am to please proceed with the FDP. Over to you, ma'am.
Thank you, DeCruz madam. Let us proceed to the second session of this one-day International FDP. I feel extremely delighted to introduce the speaker for this session, Tejas Borse, alumnus AISSMS COE, who will be highlighting various case studies on construction engineering. Tejas has completed his Master's in Construction Engineering and Management from University of Texas at Arlington, awarded Outstanding Civil Engineering ME student 2019-20. Currently, he is Project Control Engineer at Superior Construction, Indiana, USA, and also has experience as an Assistant Project Engineer. He is registered as Engineer in Training in State of Texas, adept at estimation, P6 scheduling, CPM, project administration, document management, quantity and progress tracking. He is associated with the following organization: Construction Management Association of America, North American Society for Trenchless Technology, NSBE Collegiate Member, UTA Chapter, PMI Member, DBIA Member, Southwest Division, International Peer Advisor, UTA OIE. Now, I invite Tejas to enlighten our audience with his practical knowledge in the field of construction management. Over to you, Tejas.
Thank you so much, ma'am, for the introduction. Let me share my screen. Is the presentation visible?
Yes, Tejas, yes.
Okay. All right, so Josh really gave us a good idea about the background of infrastructure industry and everything. And I'm also going to advance upon his presentation. So my presentation would mostly focus upon the case study, the how project, infrastructure construction project. So getting started with the presentation over here right away. So the approach we will be taking today, the divided in 5 parts. The first section would be paradigm, understanding what is our perspective for this presentation. And next we will move on to section 2, that's genesis. So genesis is basically where the requirement comes from. How the pre-construction process works. And section 4, we will be dealing with management, and section 5 is the actual construction process. In section 5, I have really great real life project examples, snippets, pictures from project that I can share so that you all can get a proper idea of what it is to go out and actually construct something. So getting started here, section number 1, the paradigm. So a paradigm is a way of looking at something. So within the civil engineering industry that we all are in, there are different disciplines or subjects or sectors, we might say, like geotechnical, structural, transportation, urban planning, environmental, surveying, and construction. So today we are going to set our focus on the construction aspect of it. Structural and geotechnical surveying are more traditional disciplines of civil engineering, where we all, it's very common, but construction is something that is very rapidly changing as per the needs of the current market or industry. So construction engineering is a discipline that basically deals with designing, planning, construction, and management of any project. Construction engineers do need to have a civil engineering background because that helps them in implementing or managing the scope of the project. So it's very important, or it's not compulsory, but it's recommended that construction engineers would have a civil engineering background. Construction engineers don't have to deal a lot with design as structural designers have to do, or transportation engineers have to do with their traffic planning and everything. So construction is more of a mix between engineering and management. And that's what makes it very interesting. So the primary responsibilities or focus of a construction engineer is to concentrate on how the project is being delivered. That includes the procedures of construction, the methods that are being used, controlling the cost, the budget of the project, controlling the schedule of the project, and also managing the whole team. So basically, the the aim of a construction engineer is to ensure that a project is delivered on time and on budget. So to sum it up all, the aim is to deliver a project on time and on budget. So here we'll talk about history of how infrastructure came into existence, or how it transitioned from early stage to where it is right now. So here you can see, like in early 1800s or 17th and 18th century, as the commercial travel and developing, there was a need felt for the first time for an infrastructure thing. Before that, it was just roads which were paved with like soil roads and unpaved surfaces, and it was not organized at all. It was in 17th century that first time the need for a proper and organized infrastructure came into existence. And after the advent of automobiles, it just grew exponentially, because automobile means that it requires a paved surface. So that is what pushed the development of infrastructure as we know today. The first ever highway, which we can say a true highway, opened in 1924 in Italy. After that, in 1929 in Germany, and then as per the Federal Aid Highway Act in the US in year 1956. So you can see over here from the left side how it transitioned in early 1800s to 1900s, and the road that we have right now in 2000s. So talking about India, in 1998, you can see the difference is quite substantial over there. The rest of the world started from 1929, 1956, and we had a National Highway Development Project commissioned by our government started in 1998. So almost 50 years later. One of the first infrastructure projects that came into existence was the Mumbai and Pune Expressway that became functional in 2002. That was India's first 6-lane high-speed access control tollways. This point is important because it's important to understand that infrastructure in India right now is not very old. It's relatively new as compared to that of in the US or in Germany, which is 60 or 70 years old. So you can see in India, it just started in 1998. So it's not that old right now, but it's getting there. So that's how the construction industry in India will be evolving going ahead. And that's the challenge that we as civil engineers back in India have to face going ahead. Because one of the things is most of the projects in India right now are greenfield projects. So a greenfield project is the one that is developed on a completely vacant site. So basically, you just plan a project and then build out a project on a completely blank set of land. So there is nothing in place. But going ahead, it will be, as the infrastructure ages, we would come to a point where we need to address those aging infrastructure. And then the engineers of that time, maybe 20 years after today, maybe 15 years after today, would have to address a whole set of new challenges with a project not being a greenfield project. So this is a picture from around when it opened in 2002, and the next one is in 2019. So you can already see the existing infrastructure is not at all enough. So some statistics over here, as per 2017, 1.94, not even 2% of the total roads in India is considered as national highways. So we don't have a lot of national highways. There is a lot of scope in developing national highways. And currently in 2021, it's just 1,600, almost 1,600 kilometers of expressway are operational in India, as compared to like 40,000 kilometers of just highways in the rest of the country. So we have a lot of scope over there to grow as a market and as an industry. And as the industry grows, the need for a professional also grows. And that's where we as construction engineers or civil engineers come in to fulfill that requirement. So the present scope is that, like in India, we have tremendous scope, as we discussed earlier. But in more developed economies like the US or European economies, the existing infrastructure is in need of upgrade or redevelopment. So the nature, where US and the rest of the world, developed world is today, right now, we are heading in that direction in the coming years. So, discussing upon how do we know when a project needs to be redeveloped or upgraded is the design life for a pavement surface is usually 20 to 30 years. It depends upon the requirements and the designer and the design of the local authority over there. And bridges typically last for 50 to 75 years. This is just the life of the pavement and the bridges. And if we see at recent trends of growth back in India, the passenger traffic is growing from 12 to 15%, and the cargo traffic, which we know as trucks, it's growing at a rate of 15 to 18%. So if you average it out, we can expect a 15% growth in volume of the traffic that our roads need to handle going ahead. Are we increasing the amount of highways by 15% every year? We have no data. I have no data on that right now, but I don't think we are keeping up with that number. We are building 15% roads, but highways not necessarily. So given these facts, it's safe to assume that in the next 30 years, almost all the highway infrastructure that we have built so far and that we are currently building will either one be insufficient because of the growth of the volume of traffic or be unserviceable because it has reached its service life. So, or both in worst case. So in the next coming 30 years, the focus would shift from putting new infrastructure in its place to maintaining and upgrading the one that we actually have. That has been the trend here recently, so I expect at least going ahead, we would be seeing similar, if not exactly the same kind of trend back in India as well. And it's very important for us as an industry to keep adapting and evolving to face these new challenges that were not faced by the generation that was, as they were engineers, they had land to build upon, they just went out and built things. Now, when we will go out after 15 years, we have infrastructure already in place and we have to keep that running and think about developing it and building new one. So it's added challenges. Moving on to the next slide. I would be presenting a case study of life cycle of an infrastructure project so that you all can have a perspective into what it is to be like in construction industry, what different disciplines there are, and give you a general idea about how construction is. I won't be specifically discussing very common disciplines such as structures, bridges. I would be more focused either not implemented in India or either are very new, so that you guys can have different topics to think upon for your projects or just new idea that generally is not implemented in India. So that's what I would be mainly focusing upon. All right, moving on to section 2, it's the genesis. So genesis is how the requirement is felt. So inadequacy, I think, is one of the most important factors in the need for change. So there is a small decision chart that we have over here. The question we have to ask is the current infrastructure enough? If the answer is yes, what we need to do? We just need to react by maintaining it in a safe condition, structurally and for the public to travel. It's good up till the design life of the project is reached. But what if the current infrastructure is not enough? There might be two reasons for that. One I see is either it reaches its design capacity. So all the highways are designed keeping in mind the volume of traffic it will handle daily on the peak hour basis. So if a certain highway section or an interchange is designed to handle 50,000 vehicles at its peak capacity in an hour, and if the area grows and there are like 70,000 vehicles right now going there, it will cause traffic congestion. That's what I mean when I say it's reached its design capacity. It is design lifespan. When I say design lifespan, that means as we age, as we grow old, infrastructure grows old as well, and it needs replacement and retrofitting. So if that's the case, we need a complete redevelopment. But if the capacity is reached, we have two possible solutions for that. Either we can upgrade the infrastructure or the upgrade is not possible. what may be the scenario in this case? Upgrade is possible when we have land to expand the roads or whatever infrastructure. Then we can just add a project extension. Like I would like to point out a project between the missing link project between Mumbai and Pune, the Mumbai-Pune Expressway. So there is a tunnel, an 8-lane tunnel that they're constructing inside the Sahyadri mountain ranges, below the city of Lonavala, which would be connecting the, which would be bypassing the Ghat section of the road. So an extension of the project. So it's just the small part that was missing, and then they're putting in place because it's possible. So what are the scenarios when upgrade is not possible? So take an example of the intersection near our college, which is near COEP. So they already put bridge over there. There is no space on either side to expand. In that case, it's good for now. Right now it's handling the 20 years. The traffic will grow, obviously. And if it's insufficient to handle the traffic, we cannot upgrade it because there is no space. So that is the classic case where we will be needing a complete redevelopment or an alternative solution like a tunnel in that case. So moving on to next slide. As we discussed in the earlier one, the possible solutions would be maintenance, extension of the project, redevelopment of the project, or alternatives. So when would we go for maintenance of a project? That is when the current system is adequate, it's handling the traffic well, yes, we will go for maintenance. When the cost and impact of maintaining is economical and practical. So if it's cheaper to build a new project instead of maintaining it, it doesn't make any sense to go ahead and it makes more economical sense to just demolish the whole thing, place a new project. One of the points, like when there is no future demand projected in the region, so if the region has stopped growing, if there is no future increase in traffic that's projected, then that is the case where we don't want to invest a lot again into redeveloping those projects. So that's where we can just maintain the current infrastructure because there is no demand in the future. And the last point is like saturation. It's the same. If it's saturated, there is no growth. We can just keep on maintaining and retrofitting the projects until the design life is reached. Another solution is extension. So that's what we discussed earlier. If the current system is inadequate, the solution that we would possibly choose is extension. Also, if the cost and impact of maintaining is justifiable. So yeah, extension is like it's cheaper to extend that project, maybe extend 2 lanes or 3 lanes instead of putting a whole system into its place. It's more economical and justifiable, then we'll go for extension. Future demand is projected. That is one important aspect. If there is future demand that's projected, like if the policymakers think that the region is growing and there will be substantially more population and more traffic in that region, then we would surely go for an extension. And last for extension is the system remains technically sound after minor maintenance. So yeah, for extension, it's important that the design life is not reached for the infrastructure projects, that it is still in good and serviceable condition. Moving on to the next solution, it's redevelopment. So if it's not maintenance or extension, it's redevelopment. So I'm not going to go through the list because if it's not maintenance, it's not extension, we are just left with one solution, that's redevelopment. Not one, there are alternatives, but most practical path is redevelopment of the system. And then there is a whole different sector of construction that we have not faced yet, is the alternatives. Like Hyperloop. It is an alternative transportation solution, which was, I think, proposed a few years ago between Mumbai and Pune, but I don't know what the status of that is right now. But there is sure a Hyperloop project that's coming up in San Francisco, California somewhere, and one in Dubai as well. So that's something to look out for. If that things are possible, that's a new area that we all, like nobody has experience in that kind of infrastructure and how it will impact the life. So this is some new areas of studies that we can focus on in future. And other alternatives are like creating a metro rail. That's what's happening right now in Pune. They're putting in place a metro rail system. That's a light rail to divert the traffic from road to railways. So that will take so that the design capacity is maintained. So these were a few of the solutions that are possible in case of an infrastructure project. So how do we decide like exactly what needs to be done? So the agencies that are responsible, like government agencies in case of India, they would study all the parameters. They'll compare all the parameters financially, practically, and then they'll choose one optimal solution for that. So what is industry's role in assessment of these options? Because government agency is more into administration. It is we as civil engineers and construction engineers that really need to provide the technical aspect to the government as advisors of the government. So government agencies usually rely on industry experts to provide technical assessment of the solution. There are many companies that have the resources to carry out technical analysis and provide reports to the government so that they can make informed decisions. Excuse me. Such analysis would require like a whole new, a whole specialization. It's not a thing that a small department can do. It requires a lot of resources. Moving on to the next one. The owner, section number 3. So that's the government part of that. So we discussed in the section what is the need or what is the requirement of a transportation project. Now we are moving on to C, which will discuss more about how the scope is finalized, what are the factors that go into considering the scope of a project, and how a project is put into place for industry to construct. Excuse me. So scope, this is the first and the most important thing in any construction industry. Like first thing that we need to do for a project, may it be an infrastructure project, a building project, wastewater project, any kind of thing, we need to first determine the scope of the project. Having a clear scope statement will ensure that everybody involved in the project will exactly know what to expect, and that each required step is taken and project is successfully completed on time. Scope is like, so in very simple term, scope is what needs to be done, is the definition of the project. So whatever is in the scope is in the project. Whatever is not included in the scope is not in the project. It's as simple as that. So it's very important that before going ahead with any project, we exactly identify what the scope of the project is. If we do not do that, then we can have many problems as we go into construction. Like if we do not identify something that needs to be done, now there are added costs. Now our schedule is getting out of control because we did not include that in scope. So we need to study the scope really in deep and make sure that our scope is well defined. So defining the scope would generally include the project manager with all the other stakeholders like owners, consultants, the public in case of a government project, all come together, and it's a long process to develop the scope of any construction or infrastructure project in that sense. Moving ahead, I would like to just enlist some important aspects that are to the management of the scope. So it's always advisable to have a plan for everything. We just, if we don't have a plan, we won't have a direction for the project. So it's very important that we have a plan for scope management. So that would include the process of creating scope management plan that documents that how the project scope will be defined. So this plan would exactly list out the process of managing a scope or defining a scope. Then we will be collecting requirements, defining scope, creating a WBS, validating scope. So validating scope is also very important. The process of formalizing acceptance of the completed project deliverable. So validation of scope is when we decide that we have to do something, we have to validate that that is practically possible to deliver. So that what comes into validation of scope. And then the last is scope control, that our scope does not expand or get out of control. That is aspect of scope control. Moving ahead, what delivery methods are there for us to be working on a project? So this slide especially is very important because this is how construction industry or companies like ours gets project to work on. So it's really important to understand what kind of delivery systems there are out in the market, which can be used to get the project or to get the work from the government or from any agency. So this is more important to understand what kind of system it is and to better align ourselves into one or other type of the system so that we can be prepared for whatever we need to do as professionals after we complete our education and everything. So I'm just going to go over the list of what systems we have. You might have already heard of most of. We have construction management at risk, CMR, one of the common systems of project delivery. Then we have the most common one, that is design bid build. That's usually used by most of the government agencies. Then we have the star of the show, that's design build. This is the most prominent. Delivery system used right now, at least in the United States. Almost 60 to 70% of projects are design build projects. I recently attended a workshop for design build arranged by Design Build Association of America this week on Monday and Tuesday. So yeah, this method is where the industry is heading out right now, and it's good for us that we be prepared ahead of time about the challenges that are yet to come in front of us, which design build would help us to address those challenges. And then there is multiple prime. So once we choose what kind of system we need for the project delivery, then we need to select what procurement system we want. Procurement system is how are we going to select a proposal. So are we going to select the proposal that is lowest in cost, or are we going to select a proposal that gives us best value, or are we going to select a proposal that is best qualified? That is the decision the owner needs to make on their side. And it can depend upon various factors. If budget is the constraint, probably the owner would like to go with the lowest bid. But if the project is of complex nature, and the owner would want that they would select on qualification basis, because if it's a complex project and you don't want it to be messed up, that's why you see if the company or the person doing the project is well qualified to do that level of complex project. So that's what defines the system of procurement. And finally, there are contract formats, where how are you going to get paid for the work you do? Are you going to get paid one amount and then you manage everything within that? Or you are going to get paid on progress of the work you do, or unit price based? So that's again more of the administrative part of a delivery method, but very important delivery method. If students want to take note, design build is the most prominent one. If you want more information, it's a very good topic to get more information upon. Moving on to the next one, we have request for proposals. In India, we usually call them tenders. So whenever owner has decided their scope, okay, I need to develop a certain project. Now they need to get tenders from the private sector. So they put out a request out on their website, in newspapers, that this is the project that we have defined and we need to work on. And they set out a date and general information about the project. Whatever information they have, they just provide to the contractors, I must say. So that is the request for proposal that the owner sets out after they have one, defined the scope of the project, and two, secured the funding. So once the owner knows what they need, what project they need, and two, they have secured the funding for that project, after that we can just ask for proposals. So moving ahead to the next one is bidding. So once the owner displays their intent, like, okay, we are interested in building this project, we have this much amount of budget, or sometimes they don't put out budget in upfront, it's just we want to get this project built. And then whoever the interested parties are, mostly the contractors and construction companies, they study and analyze all the plans and specifications, all the data that's provided by the owner to the companies or the contractors. They estimate, they make an estimate based upon current market prices, based upon historical information that's available. They develop whole estimates. The major part of estimate is quantity takeoff that deals with calculating how much volume of materials goes into what equipments we need and all that thing. Once you have an estimate, you need to price it. So you put your price, you put your profit margin, you put your overheads upon that, and you come up with a price. And you make a package and you submit that package to the owner. Like, here you go, this is my price. This is how am I going to do it? And it's the whole proposal. So it's basically telling the owner that this is how we are going to build it, and this is the cost for which we are going to build it. So over here on the slide, we can see two proposals. It's an example, proposal 1, proposal 2. You can see proposal 1 is supposed priced at $10 million. ATC stands for Alternative Technical Concepts. ATCs, and then scheduling is 9 points. Experience is like the past experience for the contractor, and then management plan, how the contractor or the construction company is going to manage all the construction. Then there is risk mitigation. This is one of the most important topics, risk mitigation. There are multiple kinds of risks that are there to a construction project. So how is the company going to mitigate that risk? If something happens or something arises, is there a risk management plan that the company has or the contractor has in place? Is the contractor insured just in case of worst case scenarios? What if there is a natural disaster? What if there is an earthquake and it puts construction out of schedule? So those are like risks that construction industry faces. Excuse me. So these are some of the points or some of the criteria that the proposals are rated upon. So this is proposal 1 and proposal 2. So proposal 1 is $10 million and proposal 2 is $12 million. So the lowest one gets 10 points. And the second lowest one, 8 points, are calculated on the basis of the difference between the two prices divided by the lowest price. So the difference is $2 million minus $10 million. That would be 10 minus 2. That would be $8 million divided by the lowest proposal. That is 8 points. So it's basically 18%. So the higher the price goes, the lower the points that a proposal receives. Same goes for alternative technical concepts. This proposal 1 from contractor 1 might be, they might have good concepts that they have proposed, so they get 8 points. They might have proposal 2 should have better concepts that they propose, so they get more points. So like this, a proposal is scored, and then we use the method of weighted average. So according to the need of an owner, or the owner decides how much weightage they want to give to each criteria. Like if some projects which are budget constrained, which are very much controlled by the amount of funds we have available, price is a major factor. So we can increase the percentage, the weightage of price. Suppose it's the primary concern is funds, then you would increase this to 40%, maybe 50%. But if the major concern is management, then you can increase the percentage of this, reducing the percentage of price. So the point is it should sum up to 100%, obviously. So final score proposal 1 gets is 7.15 and proposal 2 gets 8.5. So proposal 2 is going to be selected. The point to be noted is proposal 2 is actually higher than proposal 1 by 2 millions. But because management plan, experience, risk mitigation, these are also important, and these have almost equal weightage to price. That's why proposal 2 is selected, even though if it's expensive than proposal 1. So it is a misconception that only the lowest price needs to get selected. Depending upon the owner requirement and the complexity of the project, the proposal which has best value needs to be selected. So this is an example of what it means to have the best overall value for the proposal and not just money. All right, moving on to the next one. Yeah, choosing by advantage. This is one of the charts that Design Build Institute of America uses to make a decision. These option A, B, C, D, E, and F are different proposals. And amount of awesomeness is the value of the proposal that we have. And this is the budget. So consider here option number E. It is the proposal with the most value, but it is also expensive. So if you move from proposal E to proposal B, you see there is a significant difference of cost, but there is a very slightly less difference in the value. So it is up to owner. Do they want to pay substantially more amount of money for a small increase in value, or they are okay with having a little bit less value but saving a significant amount of money? So this is kind of the method of choosing by advantage, and you can find more information about this method on Design Build Institute of America's website. They have a lot of free resources available, so if anybody is interested, you can go and look up more regarding this topic. This table over here demonstrates what is the probability of different kind of delivery methods and what is generally the industry standard selection criteria for that. So you see design build, build, that is the general method where all the plans and sets are developed. Government puts out that for bid, contractors estimate, contractor put tenders in, and then the lowest one is selected. So that is the traditional method. That is changing as we are progressing ahead. This method is getting. I'd like to point out integrated project delivery. Integrated IDP is a delivery method which is generally used on highly complex project, and I'm saying highly complex project because integrated project delivery system is where the designers and constructors and everybody gets staged, and it is very technically specific, specialized project. So if it's a specialized project, you don't have many contractors that have same kind of experience. You have certain contractors that have that qualification required for that kind of project. So qualification is the governing criteria. So one example is a nuclear power plant. If you want to build a nuclear power plant, design bid wouldn't work because nuclear power plant requires certain level of specialization. It's not that everybody can go and do. So that kind of power plants usually use integrated project delivery, where the best qualification is the main criteria, because you don't want to have anything that's less than best for a nuclear power plant, given its risk associated with that kind of power plant. So that's integrated project delivery. All right, moving on to the next one, the award of contract. Now, how we moved from getting an idea of the market to owner defining the scope to requesting for proposal, we sending a proposal. Now our proposal is selected. Now what happens? Now the contract is awarded. So what we need to make sure when the contract is awarded or we get a project, read the contract, look what it's in there. If you have any omissions, if you have any doubts, if you have questions before signing the thing, make sure you understand the scope of the contract exactly before getting into any kind of commitment. Resolve any questions. Keep accurate and well-documented records. This is one of the most important things, I think, because on big projects, keeping a systematic and traceable records of the submittals or the correspondences is extremely important. This is one of my main responsibilities, to make sure that everything is recorded and in a systematic manner so that we can look up whatever documents we need or whatever plans that are needed. Thousands of documents. If you want to search any one document, if you are not organized, if you're not systematic, you are never going to find it, and that's a big disaster. So This is one of the points that we need to really focus upon. And then determine responsibilities of personnel. So who will be the project manager? What is the organization structure? Plan about your subcontractors and everything. So that is all in the award phase. We are going to discuss that in more depth going ahead. All right, moving on to the next slide. We come to the most interesting part. That's what goes into managing a project of this level. The slides that you see here is very much reflection of what we are actually doing over here. So I have not mentioned the names and the exact examples from the project, but you can assume that this is how the projects are executed, at least here in the United States. So it's very relevant to what the real industry is. So there is pre-construction in management. So now you get awarded your contract and you have to go out and build the job. But you can't just go out. You have to make sure that you have management plans, you have everything scheduled, everything estimated for, and you have all things ready before you can go out and construct something. So pre-construction, very extremely important in project success, because if you don't plan things out, you are not going to build it in an efficient way. So in order to build it in the estimated cost, very much important to manage pre-construction, very important phase. So pre-construction is necessary before the actual construction begins. It is important to help analyze, plan, design, and establish the needs for a construction project. Pre-construction purpose is to ensure that the project is clearly defined in every detail and that it is executable in all aspects of construction. So constructability, it's one of the most important aspects. So that is the whole idea of pre-construction. So going ahead, we will discuss few important aspects of pre-construction. So here are the important thing that goes in. So I'll just go over the list and then we'll discuss few of them in detail. One is engineering assessment, assessing your drawings, looking at your drawings, looking at your proposal, how you are going to engineer that thing. Is it possible? Is it practical? Is it how you are going to put it into place? That's what goes into engineering assessment. Then initial design and development. This is more for a design build project where you don't have set of plans already developed. Design build is a system where owner just says, hey, I want to build a highway. That's it. And then they have like, I want to build a highway over here. And then they select a contractor, and then the contractor jumps in and like, okay, now the contractor and the owner, they together work to develop the plans and the designers as well. So that is design build. In normal bid build, you have set of documents ready by the government. Government works on the documents, contractor is not involved. Government hands over the plans and drawing sets like, these are the plans, go and build it. So in traditional method, contractor doesn't get to choose how he wants to build the project. Whatever is on the plan, he needs to build it. But in design development phase, the contractor or the company who has technical experience and technical capabilities get to work with the owner and the designers in developing the plan, so that if there are any issues related to constructability, if the contractor thinks that this is not going to work, this is the designers say you have to put it over there, but the construction engineers, we know that it's not, there is no way to put it that way. So we can address that at a very early stage instead of at a later stage when all the design is developed. So that's why initial design and development is very important in pre-construction. Then defining the scope and roles and responsibilities of all the parties involved, budgeting the outlines and assumptions. So during our bidding process, when we say we are going to build it for this amount of money, what were the assumptions we made before giving that price? It's very important what kind of assumptions we made, what equipments we are going to use. It's important to have a clear plan and idea of what were assumptions were and how we are following assumptions. Because if we decided in our schedule, in our estimate that we are going to use this equipment, but if we use another expensive equipment, that's where we lose money. Contractors or the companies lose money and the project runs out of budget. Because not of the one thing, but such things accumulate to form a large budget creep or scope creep, and this can damage the project in long run. Then scheduling, setting important milestone, constructability reviews, utility requirements, procurement, logistical planning, equipment list, estimating, risk analysis, value engineering, cash flow analysis. These are all the aspects of pre-construction. We're not going to discuss all of them in detail, but we are just going to discuss few of them in detail. So one of them is deliverables checklist. So what are deliverables? Deliverables is like when you get a project award, it's the first thing you need to do. Before going out to the construction on site, you need to have your project management plan in place, your quality management plan in place, environmental management plan, safety plan, public information plan, your document management plan, your aerial drone imaging plan. All your permits need to be available and ready from the government. Subsurface exploration, this is more related to geotechnical engineering. Then you have hazardous management plan, you have construction noise abatement plan, construction vibration monitoring, pre-construction survey, transportation management, traffic incident management, utilities, and DBE-EO. These are all the plans that we had to submit on the project that I'm working on. So this is not a list which is suggested. These are the actual plans that we had to work on and submit to the government before moving on with the construction. So each of this plan, it requires input from construction engineers who have a civil engineering background in order to develop this plan. Just take for example, construction noise abatement plan. It takes a construction engineer, a civil engineer, to understand the process of how the bridge is being constructed and what kind of noise it will create, what kind of vibration it will create. If you have the understanding of that, you are in a position to develop such kind of management plans. So I just want to highlight how things relate to each other and why it's so important for us to have a clear idea of what we need to do for different kind of management plans. Moving ahead, we have submittal schedules. Then we have like management submittals, we have design submittals where we submit plans and everything. We have construction submittals where we submit shop drawings, concrete mix designs for approvals. We have payment applications and construction updates, everything. Then we have reports, traffic reports, progress reports, and all kind of reports. We need to have an idea before the project starts that when all of these needs to be submitted, because it has a deadline. We'll have a look at the schedule on the next slide. So this is a sample submittal schedule. Generally, it lists what needs to be submitted and what specifications and what is the required date for the submission. Like for example, traffic control, we need to submit the barrier wall certification, or we need to submit the worksite traffic supervisor certification. For demolition, we need to submit the demolition plan. Pile driving, we need to select the equipment data form, what equipment we are going to use for driving the pile, which Josh discussed in the earlier presentation. So structural steel, concrete. So like there are different kinds of things which goes into construction, and we need to be sure that we have all the things needed in place. Same for paving, miscellaneous, and painting. Moving on to the next slide, is the document control system. As we discussed earlier, it's very important for us to manage systematically all the documents that we have. The document naming convention is important. Revision control is very important. The status of the documents is very important. Review processes, numbering, these are all the important aspects in any kind of management system that we have for construction projects. Here is an example of a system that we use on this project. You can see we have technical requests like a deviation request, we have non-conformance reports, we have RFIs, request for information. Then in submittals, we have change orders, construction reports, correspondences, design submittals. And these are all the plans. We have numbering for them, which are systematically numbered, which are systematically named, which show status, which shows all the dates. So it is a very very intuitive system where you can record your construction progress as it happens. So this is what I mean when I say it needs to be systematically recorded and managed. Moving on to the next slide, subcontract and suppliers. Any contractor doesn't have the capacity to do all the work by himself. We need subcontractors which are specialized, like for mechanical, electrical, plumbing, we need a separate subcontractor. For electrical, we need a separate subcontractor. Heating systems, separate subcontractor. So we need to identify what work a contractor can do and what work a subcontractor needs to do. And from our budget and our plans, we need to give that portion to the subcontractors, which we already considered in our estimate that this is the scope and this is the budget for the subcontractor work. So we need to decide that at an early stage, what work we have to do in-house within the organization and what work we have to subcontract. So generally the work which requires specialization is the one that gets subcontracted, which is not done in-house. Here you can see a structure, like there is owner, then there is general contractor, and then there are different subcontractors working for the general contractor. So it just gives an idea of how where the subcontractors are placed within the organization structure of owner, general contractor, all the way down to suppliers. Important step, subcontracting plan. Same, if we are going to do something, we should have a plan ready. Then as owners request quotation, in subcontracting, we are the owners that are selling our scope. So we have to request the subcontractors a quotation. Then we have to evaluate different quotations and decide that which option is the most feasible for our organization to go with. And then fourth is set up a contract with them and get them on board, provide them all the documents they need, provide them a copy of how our organization is following all the plans so that they are on board with all the construction processes that need to be done. The next important aspect is scheduling that needs to be done before a project. So scheduling, it creates a timeline for every task and every event in a construction project. The schedule is a very important and very fundamental part of any construction project. You have to have a detailed schedule in order to have a successful project. So this is one of the sections of civil and construction engineering. So scheduling generally needs a person with a construction and civil engineering background, because you have to break down each activity into each work process into different activities. And in order to identify the activities and technical challenges that we face in installing that things, you need to have a civil engineering, structural or civil engineering in general kind of background in order to effectively put in place a schedule. So we are going to just see a very small example of a schedule. I consider a small concrete pour for RCC pad. What are the possible activities? We need to mix the concrete, we need to have steel rebar, we need to have formworks, we need to strip the formwork, we need to cure the concrete, clear the land. So this is like all the activities are identified, involved in that process. Next, we need to prioritize, make a sequence of those activities and allocate the duration. So like cleaning the land, for example, take 1 day, installing formwork, take 2 days, and so on. The next step we need to do is set up an activity. So whatever activities we identified, we are going to set up a network. I'm sorry, I mean to say network. So we have different activities like this. So we have to start it, the cleaning the land, formwork, installing rebar. It's like all in sequence. So number C is where I want to point out this activity. We can cut steel on day 1. We don't need to wait until the formwork is done to start cutting the steel. So that's why you can start it on day 0, but you cannot, for example, install spacers until the steel rebar is installed. So this activity needs to start when this activity is finished. That is the basic concept of how to establish a relationship between activities. And then you put the duration for the activities. And this is one possible way of reaching to the finish from the start is by this path. It will take 14 days if we follow this, 1 plus 2 and 1, 0 and 7 and 1, that's 14. Or there is this possible path that we can follow to reach the finish of a project. That path will take 13 days. So we have 2 paths identified. The path with the longest duration is generally the critical path, and that critical path is the shortest time possible to complete the project. You need to understand this thing very carefully. It's the longest duration path, but that is the shortest time possible that's required to complete the project. So that's a very simple example of how scheduling activities work. Real schedules for big projects have thousands of activities. Here is a sample schedule that we have from Primavera P6, a very important tool that we can use for scheduling. You can see it's divided by first floor. There are different activities in there. In second floor activities, you have start date for them, you have finish dates for them, you have all the durations for them. And on this side, you can see all the activities and how they are linked to each other. The red one shows the critical path. Primavera P6 does that for us automatically. So we don't have to worry about doing the networks ourselves. We just have to identify the activities and put them into the software, and the software processes it for us. Okay, we are done with pre-construction. The next step is mobilization. Now we have satisfied all the requirements that were needed. We gave all the plans to the management, to the owner. We developed all the management plans. We did all the scheduling activities and whatever is necessary for the pre-construction thing. Now we are mobilizing. Mobilizing is actually going out on site and setting up a site office, so that and moving your equipments, moving your personnel on field. So it's basically getting your boots on ground. It's the first time we go out, set up a fence, set up office, move equipments. It's getting ready to get into the construction phase. Construction NTP. So when we satisfy all the requirements that are needed for this kind of a construction project, the owner, in our case, the government, gives us notice to proceed that yes, you can go ahead with the construction. And once we have the construction NTP, then we can start actual construction process. Like, believe me, for the last 7 to 8 months, we have been working only on the pre-construction phases to satisfy all the requirements that we just discussed in this presentation in order to get the notice to proceed. So when you get this, that's when we can actually go on site and do something. All right, we are here at the last part, section 4, that's the realization, actual construction. So this section I have, because we have time constraint, I have just included some disciplines that are not very common. So I have not included structures or pavements or that kind of things, which are usually very common. So going ahead, aesthetics and landscape architectural work. So this is one of the disciplines that we have on our project, which deals with the aesthetic and landscape architectural work. It deals with how the project will look. It deals with the designing aspect, not the structural design, but the aesthetic design. So like you see over here, they have like grooves on the columns. You can see the grooves over here so that they are visually pleasing. How should be the surfacing? How should be the lighting of it? How should everything look like? That is the important aspect of aesthetic and landscape architectural work. This is a whole commitment to the project that we need to follow. Here are some more examples. Like you can see how the pavement should look like, how the joints should be cut, what color should be used, what kind of accent color should be used, what kinds of plants that need to be planted, how the street name will look like, how the project sidewalks, the footpaths will look like. Everything is specified in aesthetics and landscape architectural work plan. This is one example of that. It clarifies upon what plants we need to plant along the slopes of the highway. This all is discussed with the public, with public input. They have meetings with the public. They decide what plants need to be planted, and then we have to work on this thing and implement this aspect. So this is one of the aspects that's relatively recent, I must say. Then there is environmental. This environmental is completely different from the environmental engineering that we are aware of, like development of a sewage treatment plant or water treatment plant. The environmental commitment over here are like permits, hazardous material, then lead-based paint, noise analysis, air quality, construction noise, construction monitoring, environmentally destructed, do not disturb zones, best management practices for work, terrestrial wildlife minimization, all this kind of thing. So one of the unique requirements on our project is, in the state of Indiana, we have this snake called Kirtland snake that is an endangered species and it's protected by the government. So for that, we had to install a silt fence all around our project limits so that we are not disturbing or we are not impacting, or we are actually impacting, but we try to minimize the construction impact on the local wildlife that's available around there. So that is one of the unique aspects we have to our project over here in the state of Indiana. The next important aspect for our project within environmental is vibration monitoring. So this project we are working on is in an urban setup. So there are a lot of houses, businesses, establishments around the downtown, around which we need to work. The work involves demolition of bridges, driving of piles. So it creates a lot of noise and vibration. So what we had to do was install these seismic sensors, which can detect the movement in earth. So these sensors are used to detect the earthquake and the movement in the earth and everything. So we had to install these kind of sensors all around the project and monitor them continuously for the limits that are set by the government. So these are the limits that are set. If we exceed the limit, we have to stop the work and reassess our processes. So why this is important? So we as construction engineers need to address this issue. So we can't stop work because it's creating vibrations, but we also have to maintain the vibrations to a certain limit. So we as construction engineers have to face this challenge of going ahead with the project, going ahead with the work, and still maintaining the limits of government. So it is a challenge to work in a way that would be under the limit, but still get our work going. So that's why I found it important to mention this under environmental. Next one, we have drainage. Drainage for a highway is very different. Like we create small holding zones. Whenever there is rain, all the water can temporarily go here and then seep into the ground. We have culverts, and over here you can see this is actually kind of a lake. So this is runoff from the rain that goes here. And this is drainage is important because we are disturbing the topography of the land, and if we disturb it, if there are natural flows, we interrupt them, they might cause local flooding. So it's very important to address the drainage aspect of a project. Moving ahead to the next thing, lighting and traffic. This is one of the interesting disciplines of civil engineering and construction engineering, where the design and installation of lightings and traffic signals has to be done. It depends upon two factors: if the highway is elevated or depressed. If the highway is elevated, the local roads will run below that. If the highways are depressed, like it's a grade separator, then the local roads will run above that. So depending upon those factors, the lighting requirement changes. Moving ahead to the next one, maintenance of traffic. So as we discussed earlier, why is it important to focus upon the construction aspect? Because we need redevelopment. Going ahead, there will be a lot of projects where there are roads and live traffic already, and still we have to work around the live traffic. So maintaining the traffic that is already on the road is extremely important, and it is one of the major aspects in our current project, because we are working on a live traffic environment or a setup where we have traffic flowing, and then we still have to do our work. So for that reason, we have maintenance of traffic. There are different kinds of guidelines that are set by ATSA, or the American Traffic Association. So we need to be considerate of that and follow that thing. So these are the things that we as construction engineers need to develop the plan and analyze the plan and submit it to the government for approval if needed. Moving on to the next one, this is a sample MOT plan, maintenance of traffic. It shows where the work is going on and how the traffic is going to be diverted. So you can see over here, the work is going on this lane. So they are putting up a lane closure, and then the traffic has been shifted to the other two lanes. And then green one indicates the traffic is flowing normally. So this is the section of the road which is restricted. So that's what is meant by maintenance of traffic. In here, you can see how the lanes are shifted so that these lanes are available to work upon. Moving ahead to the next one, these are like different signs and things that can be used in maintenance of traffic. One important resource that the students can go and look at is the Manual on Uniform Traffic Control Devices, MUTCD. This is a free resource available online. So if you want to have more information about it, you can look it up. And it's coordinated by ATSA, that's American Traffic Safety Services Association, who's responsible for ensuring the traffic safety and everything. Moving on to the next one. This is how a MOT plan looks like. This is a road, this is the work zone, and how we have to put barriers over here, and how we are going to put up the signs, at what distance we are going to put signs, and what signs we are going to put so that the traffic is warned ahead that there is work going on. This all comes under planning for construction aspect. Moving ahead with the next one is the intelligent transportation system. And we have a lot of this going on in India right now by the means of electronic toll collection. We have ETC tags. We have red light cameras in the city as well. And then there are different things like ramp meters. We have traffic signal coordination. We have live CCTV monitoring. We have traffic signal priority. We have traffic information system, the traveler information system, sorry. So these all form the part of intelligent transportation system. So intelligent transportation system is like the next thing, that it's like integrating technology into the construction so that it can help us manage the flow of traffic after the project is constructed in a more efficient way. We can control the traffic, like traffic signal coordination is like if one traffic starts collecting a long line, it will increase the time of the green signal so that the traffic flows and it does not pile up. So that is an example of technology, artificial intelligence being implemented to recognize the volume of traffic and adjust the traffic lighting times based upon that data. So this is one interesting field of construction or transportation engineering that we are heading into, something to look out for upcoming civil engineering students, and a good topic for projects, I guess. Moving on to the next slide, we have LiDAR, 3D modeling, and aerial photography. So we have a requirement on this project where we have to submit drone photography for the progress. So it's like literally flying a drone out there. Drone has a camera attached and it captures all the progress of a project in real time. We have to do that every 15 days so that we can sit here and actually look at what construction progress happened during the last 15 days. LiDAR is a technology where you can get 3D mapping. So if you fly that drone, you will get a three-dimensional model of your work. So why that is important? Number one, it is very important in determining cut and fill. If you just fly the drone, you'll get all the elevations and you run the system. You just put your profile of road. It will automatically say how much you need to cut and how much you need to fill from what location. So that's excellent technology that's upcoming in our industry that we need to look out for as well. So in the next slides, I will be sharing some actual footage from the drones and how we can implement the 3D modeling in our projects. So over here, you can look, this is one section of the project, and this picture is captured by a drone that's flying on one of the sections of our project. And the yellow part over here is actually the quantity for the pavement removal. So we had to demolish the pavement on this area. So after 15 days, one of our team members went out and he flew a drone over the project. It captured everything. And then our engineers just put out how much pavement was demolished, and it gives a quantity, exact quantity, which is measured using aerial drones. And this quantity can be used to verify the payment that the subcontractor is charging us for the demolition. So it's a very powerful tool that can be used in different kind of ways. The next picture we are looking at, this is one of the bridges, and this is a 3D model. This is a LiDAR photography actually. So we flew a drone, it created a 3D model. It does not capture from sideways, but it captures from the top angle, but we can move it around like a 3D model. So you can see our engineers put up a 3D model of the abutment and the bridges that we need to construct. So these blue lines you see over here are actually the abutments that we are going to construct over there. And you see the filling over here. We have to fill this thing with material. So just by this LiDAR 3D model, we can calculate the amount of soil that we need to fill over here so that we can order that material as per the exact quantity. So that's where the LiDAR 3D model comes into picture. So this is an aerial photography. This is a 3D model of a location of the upcoming bridge that we are building. You see the red rectangles. These are the locations of the pier that were laid out on a software. And on the next, in the next slide, we are going to see how that translates into real world. So you see the red outline. This was made on a software, and then we went out, we flew the drone, and we overlapped the software model with the drone photography, and you can see exactly how the foundation that we made for the bridge exactly aligns with the model that is connected with the GPS with all the location and coordinates. So this is like creating a 3D model of your project, exactly how it is built. So I think this is really the way we are heading into. We don't have a lot of this back in India. We don't have the technical capacity to do it right now, at least on a large scale, on a major scale, but this is an area that we can focus on going ahead. All right, so we reach at the end of the presentation. There were multiple things that I had to discuss, but due to the constraints, we can only include this much. Next, I'm going to share with you a video. So this video is actually 7 hours ago. It happened like last night. We went out and we had installation of a precast bridge on an abutment. Hopefully this plays. Section. All right, let me play this video another way. I'm just going to play it from my desktop. We have 2 cranes over here, and as you can see, we have live traffic going on in the background. So this small installation process demonstrates the challenges that we have as construction engineers. So all the things that we discussed earlier in the slides, the management plan, maintenance of traffic, why you can see this barrier wall, this comes into maintenance of traffic because we have to work in situations where there is live traffic running at 60 miles an hour, 70 miles an hour, that's like 120 kilometers per hour. And still we have to carry on all the other tasks. So that's why it's very important to be proficient with all our management plans and all the systems so that we have all the resources we need to carry on such installation processes. We'll just go to the end of the video real quick where they set up the beam. This over here is the bearing pad over which the beam is going to be set. This is one abutment, this is second abutment, and we are going to set 5 beams on this. 1, 2, 3, 4, and 5 on the other side. So once the beams are in the place, we are going to place deck on it and then pave it. So here is a very good example of the camber that we discussed. You see this beam, it's curved. It's not completely flat, it's curved, because when we put concrete on it, the weight of the concrete will push the beam downwards, and this camber will help the beam not to sog, but to be in a horizontal alignment. So that's why we can see a slight curve over here in the beam. That's about it, the video. I'm going to switch back to the presentation. Yeah, that was almost the last part of our presentation. Just let me select the right screen. I think I selected the wrong screen. All right. All right. Brings us to the end. Thank you so much for bearing with me for the past almost hour. That's all I had to share for now. My intention over here was to give you a perspective into how construction industry looks like. And if you have any questions, just let me know, and I conclude the presentation over here officially.
Thank you so much, sir. It was a wonderful presentation and it was very informative. We have a few questions. I'll just read it out to them. As a civil engineer, which phase is most crucial, maximum attention for highest quality project?
Sorry, can you please repeat the question? My video was playing in the background. I couldn't get it.
Yes, sir. As a civil engineer, which phase is most crucial and needs maximum attention for highest quality project?
The end of the pre-construction phase, in my opinion, like when we have the designs, and between having the designs ready and going out on field to actually construct anything, the time between that is the most crucial time, where you have all the plans, all the procedures in place, how you are going to do the work, how you are going to execute the task of putting something into place. That plan is the most important and crucial part of a project.
Thank you, sir. We have next question. Sir, how can we introduce sustainability in infrastructural development?
So one of the aspects that I would like to discuss over here is we cannot make, so construction is a product that's different from other industries. Like other industries, we have a set process. These are the resources that they put in. These is the product we get out of that industry. So we can manage the input to be more sustainable, for the end product to be more sustainable and environmentally friendly. But construction is a unique challenge. Every project is different. So it's not always possible to control the sustainability of those projects. But one thing I would like to really highlight over here is on this specific project, we have to demolish a lot of concrete pavement. So the pavement that we are breaking, we are using that pavement for filling as an earthwork on many locations, so that we are not just discarding concrete and causing damage to the environment. So these are small ways here and there that we can try to make an impact to make the project more sustainable.
Yes, sir, that makes complete sense. Thank you so much. We have a question from Shantanu, a student from last year's civil engineering department. The 0.85 design methodology adopted in India, that is, design parameters should be able to handle 1:0.85 is equal to 1.18 para times the maximum possible parameters, which is the performance of structures in India. It's significantly lower than the global standard of 0.7, which is equal to 1.43 times the maximum possible parameters. This gives the room for quality compromisation. So what might be the future impact of this on Indian infrastructural scenario?
Yeah, I'm trying to read. It has a lot of numbers. I'm trying to read the statement once again. Yeah, I think that has a lot to do with how we approach, because we can do parameters that is much higher requirement standards. But then with increasing standards, it also increases the cost of the project exponentially. So from, just to put it in perspective, if you have to go from, if you have to score 90%, you have to put in efforts, a lot of efforts. But after 90%, to increase even 1%, you have to put even more effort into that. So it's almost like if you have to put X amount of effort for attaining a 90% level, then for the next 5%, you have to put twice the efforts. You can't just read something and, or you can't just put small amount of efforts and reach that level. So as the level increases, even for small amount of increment, the efforts that we need to put increases exponentially. So even if there is a small difference, it impacts, the impact magnifies on cost. And we, India being India, we try to make everything more cost effective, because capital is a fund that is not very, capital funds are not very easily available in India. So I think that might be the parameter behind using a design standard or a spec that is lower than the rest of the world, because it's not safe, it's not unsafe, it's safe, but it's cheaper. So I think that might be the thing. But I am not a structural designer, so I might not be the best person to answer it in the way you want it.
Thank you so much, sir. We have one of our faculty member asking you a question. He says, please convey the importance of drone surveying infrastructure as per the present scenario.
Yes, the surveying has taken a completely different form from what I studied back in my bachelor's degree. So we studied surveying that used more mechanical methods, like of how we do normal survey. But nowadays, in road alignment and everything is done based out of GPS and 3D models. So on our project, surveying is, we have a hub that's installed on our project site that communicates with the satellite, and then we have small devices that actually go out on site and measure the location. And our designers, they design all the curves, the roadway curves, alignments as per their designs. Our field engineer takes that model and puts it into the GPS system. So when the field engineer goes out on site, all they need to do is walk up with their device, match the coordinates, and put up a stake over there. And that's how they put out the survey alignment for the roads. So it's completely different from what I studied. So maybe that is something we need to study more, I think.
Sure, sir. Thank you so much. Prakash Nangre, sir, has another question for you. He says, in flooded area, how will you change design aspects for bridges?
Yeah, in flooded area, so the area which experiences frequent flooding, the most important aspect over there is we don't have earth embankments in that area. Most of the bridges, so when I went down in Florida, Florida is known to have a lot of hurricanes and a lot of rainfall in general. It's a much wetter place than up north. And there are many swampy and marshy lands where it's very easy to get flooded after a rainfall. So over there, I did not see any earth embankments. Everything over there was either elevated or out of the flood region. So the foundations that we discussed earlier, the Kaisen foundation, are the most common type that I have seen in flooded areas that has been used. So that foundation is like a casing outside the proper foundation the actual load-bearing foundation, and the outer casing is to protect the structural part of that from degrading. If that helps. So that is
Thank
one
you
of the
so
design aspect. That's the foundation part is the design aspect that's considered when it's a flooded area.
Thank you, Tejas. Giving us so much in detail information on project life cycle of an infrastructural project and the relative aspects with photographs and video, and for addressing the questions of the audience. Thank you so much.
Thank you.
Now I invite Preeti Madam to proceed with the FDP. Thank you.
Thank you, Shilpi Madam. I am Preeti Satarkar. Welcome you all to the third session of this one-day International Faculty Development Program. I welcome the speaker for this session, Engineer Hemant Jain, who will guide us on the topic of Future of Concrete. Engineer Hemant Jain has completed BE Civil from COAP in 1993 and MBA Marketing from Symbiosis in 2000. He is a regional technical head in the Technical Assistance and Service Cell Department, UltraTech Cement Limited, Pune region. He has a total experience of more than 23 years. He has played a key role in Aditya Birla Group Cement Transition. He is the founder member of Birla Super Shopping and UltraTech Building Solution. Now I invite Engineer Hemant Jain to enlighten our audience with his immense expertise and deep knowledge. Over to you, sir.
Hello. Hello.
Yes, sir, you are audible.
I'm audible?
Yes, sir, yes, sir.
Yeah, just I'm sharing screen, then I will start. Just a minute. Yeah, visible?
No, yes, sir. It is starting. Yeah.
Screen. Is it visible, sir? Madam?
No, sir. It is loading, sir. It is in the loading phase. We'll just wait for 1 minute.
Okay, now it's visible, sir.
Now, my sound is loud and clear?
Yes, sir.
Okay, good evening. Excellent lecture by time to go ahead because I have almost most of the things. Even though to proceed with this, I will you to Principal Dr. Bormani sir, AISSMS College, Pune Engineering College, HOD Dr. Awari sir, Professor V.R. Patil sir, Shilpi madam, and our today's guest speaker, Mr. Jose Krishnar and Mr. Tejas on the today's one-day workshop on address industrial changes or challenges. To move ahead, I really not, but being working since last 26 years in the cement industry, what are my experiences in concrete or particularly in cement? I'm going to I will going to talk on that more because our previous two speakers spoke more on the implementation part and the procedure part out of it. But the basic material which they use or use in concrete. So it's better. And one of the students also asked whether there is any substitute for the cement or concrete. So it will become interesting if I talk on those subjects particularly. So before moving into, so as you all know, in Bombay one project, durable concrete for today and tomorrow. In today's scenario, the layman or regular qualified engineers or consultant look for the strength of the concrete. But as the resources is now getting depleting day by day, is now the most important part of the cement or the concrete is the durable concrete. So how to make it durable so that it will last for years and years from on. So today's topic. Main talk of concrete today and tomorrow or future of concrete. I will talk about my organization where I am working. Just a brief description. I am working in UltraTech Cement Limited. In the cement, UltraTech Cement Limited is the flagship cement company of Aditya Birla Group. Aditya Birla Group not only is in cement, the largest cement producer of grey cement, also the largest producer of white cement, which the brand name you know all is of white. Grey white cement are also the largest producer of RMC ready-mix concrete. Along with that, there are also manufacturer of building product division. Means building product is what? AAC block, grouts, so many and so forth. So we are the largest in grey cement, white cement, RMC and BPD as far as the cement is concerned. As far as the ABG is concerned, Aditya Birla Group as a whole is concerned, we are not only in the cement, we are the largest in India. We are third largest in the world, excluding China, which I explained in my introductory remark. We are also the third largest or second largest in aluminum. Means from pin to the seats of aeroplane, what the aeroplane made of aluminum sheet, from that level, whatever the aluminum is made, the company name, one is an American, one is in India, which is known as Hindalco. So that belongs to Aditya Birla Group. And again, we are the largest producer.
Hemant sir, Harsh here.
Yeah.
Sir, your voice is not clear, sir.
Just when I check. Just give a minute. Clear now?
Yes, sir.
Clear now?
Sir, I guess your network connectivity is a little low. Please, can you just change the network? Because your voice is breaking in the middle and yeah.
Hello?
Hello, sir.
Hello? Now, is it okay?
Yes, sir. Yes, sir. Now it is audible, sir.
Just a minute, I share again. Now it's visible or not?
Visible, sir, visible.
Visible, na? Okay,
Yes, sir,
okay.
go ahead.
Okay. Sorry for this inconvenience due to this net connectivity. I was talking about the Aditya Birla Group. So, as far as the cement, no doubt we are number one in India and third largest in the world, but I am talking internationally. So, globally, as far as the carbon black is concerned, we are the, you can say, monopoly in carbon black. Carbon black is the material which is being used in tire manufacturing because tire is made of rubber. Rubber is a very soft and flexible tough material. To make it flexible and strong and durable, carbon black being added. Also, in an insulator, we are the largest producer of insulator. Also, in India, we are in telecommunication, you know, Idea. Then in apparels, Van Heusen, Louis Philippe, Peter England, all those brands are belong to Aditya Birla Group. So in financial services also we are there. Insurance, Birla Sun Life also we are there. So this is a multinational company which is in a very different business altogether. So UltraTech, particularly as far as the cement is concerned, UltraTech has a consolidated capacity of 116.8 million tons per annum, means around 62 lakh bag per day. You can understand the capacity. And 1 million ton plant require around 800 crores of rupees. If suppose you want to set up a 1 million ton greenfield plant, it require around 800 to 850 crores of rupees. So you can understand how much the investment only alone in cement business itself gone from the Aditya Birla Group per se. UltraTech has 22 integrated manufacturing unit across India. Means if you want UltraTech, that will be available across India. Wherever you go, this is not a regional or state bank brand, but it is a national brand, or you can come as an international brand, because we also sell in Brahmin, Dubai, Bangladesh, so many places out of India. 27 grinding unit, 1 clinkerization unit, and 7 bulk terminal plants. Bulk terminal 7 plants, wherein 1 plant is in Urli Kanchan in Pune, wherein raw material comes only packing done and been supplied to the required market. In white cement, UltraTech goes to the market under the brand name, what I already explained, Birla White. It has 1 white cement unit and 1 wall care putty unit. Just these are the some glimpses of UltraTech RMC plant, some glimpses of UltraTech Building Solution. UltraTech Building Solution is a new concept wherein under one roof you will get all the product which is needed from foundation to the finishing of the any house or building. So whether it may be paint, pipe, electric fittings, sanitizing fitting, anything, rainwater harvesting, pest control, anything you name it, that will be available under available at those shops, which is named as UltraTech Building Solution. And these shops, these outlets are more than 200 across India. 2,000 across India, not 200, more than 2,000 across India. These are our brand names: UltraTech Building Solution, UltraTech Birla White, and UltraTech Concrete. In Pune particularly, we sell OPC cement with the brand name of Birla Super and UltraTech across India. Particularly in Pune, we sell under the brand name Birla Super. Now, as far as the today's subject is concerned, concrete, because my 2 previous guest lectures has covered lot of things of construction, on-ground working and tendering and procurement and handling the project, everything. But the basic material, concrete. So I'm going to talk about this, what is concrete all about, and whether in the future, whether it is going to change, or as one student asked, whether there is any alternative for it. So we will go one by one. So as far as the concrete is concerned, concrete has its origin from a Latin term concretus, meaning to grow together. Concrete is nothing but the heterogeneous material consisting of inner aggregate bound together by a binder, and binder is a increase in strength in due to the microstructure development within the system. As per the experience and study of the ancient structures, concrete has a life that spans even millennia, depending on the chemistry of input, what the type of material, what the ingredient you choose, you take, you proportionate, you mix it, and you use it. That totality depends on that. As far as the concrete is concerned, it is also known as a rock-like material. But if you see, the 65 to 80% is a aggregate, whether it is a fine or coarse, or remaining 18 to 20 or 22%, 18 to 22% that goes to water and cement. Means major component as this material, which we call in a day-to-day life as a concrete, is made up of 80% is of fine and coarse aggregate. Okay, cement and water is not more than 20 to 22%, or sometimes admixture, optional. That is not every time, but in nowadays people use admixture in a major way. Previously, in ancient times, people use blood as an admixture. Okay, now because in ancient time there was lots of wars and lots of happening, so blood was there, so they people used to use blood because in a blood hemoglobin acted as a just like a ball bearing effect, so that hemoglobin of blood used as an admixture in ancient time. But nowadays the war is I pray to God war should not happen or should not be there, but it has been reduced. So now this is chemical admixture being used in a making of concrete and improving some properties of concrete. Now, the question to be answered whether concrete or whether there is an alternative to the cement or concrete. So answer is yes, concrete is here to stay. There is so far lot of research is going on, because if you see there is a lot of change in everything. Previously radio, then black and white TV, then color TV, then smart TV, then LED, even from landline to mobile to smartphones. In every field, the change is there, and change is the reality of life. I'm not denying that. But as far as the cement is concerned, since its inception till date, the scientists or the scholars is not able or not found any substitute as far as the cement or concrete is concerned. So that is going to be there for a longer time. Why? Because concrete is a versatile material. Concrete can be moldable to any shape. If you want to make a column, it made a column. If you want to make a slab, it can be made a slab. If you want to make a door frame, it become a door frame. If you want to make a paver block. If you want whatever the things you want, mold, any shape, you can mold it. So it's a moldable, strong and durable. If you know previous bridges, life is along 100, 150 years, 200 years, even a Taj Mahal, Qutub Minar, if you take the example of, as far as the India is concerned, so those structures still are durable and strong and no repair is required. So that is the one reason concrete is here to stay. Concrete does not rust or rot as steel or other things rust. Concrete doesn't rust or rot. Concrete doesn't need any coating. We do a coating for waterproofing and for anything, but particularly if you behave with the concrete in a proper way, if you follow all the rules and regulations, if you select the raw material in a proper way, mix in a proper way, place in a proper way, take care of the concrete in a proper way, then there is no need for coating as far as the concrete is concerned. And majorly, concrete is a fire resistance. So these are the things which embed us that concrete is here to stay. And one of the point which again to be added here is cheapest material available on the earth. Somebody may agree or somebody may not agree, but I will, along with the example, will prove it. Yes, it is the cheapest material, because if you see, it is made of 4 or 5 material: fine aggregate, coarse aggregate, water, cement, mixing labor, sometimes admixture, sometimes not an admixture. But particularly as a concrete as a whole, if you consider, it is a 5: cement, fine aggregate, coarse aggregate, water, and a labor. Labor, I am not talking a material, but one of the things, that's why I am considering a 5, because that is he is the most important, but he is the most neglected person in a construction industry. Sorry to say that. Sometimes it is a saying, I say, the most important person in life is the most neglected person in our life. That's the saying, is applicable to the construction industry. Take an example. The most important person, if somebody asks me, who is the most important person in my life, I will say my wife, because she came looking towards me. Okay. But if she say, अरे यार आज चलो मार्केट में जाके पिक्चर देख के आते हैं या खाना खा के आते हैं, तो मैं बोला यार no, I am tired, I am busy, we will go tomorrow. And at the same time, after half an hour time, if I get a call from my friend, अरे यार हम लोग ये रेस्टोरेंट में बैठे हैं, आता है क्या? I will say, अरे यार मैं 2 मिनट में नीचे से घूम के आता हूँ. I will give time to the friends and everybody, but I will not give time. But at the end, if somebody asks, who is the most important, is the most neglected. It's the same thing happening in the construction industry. The most important person is that mystery, or we call a labor or concrete mixer, but he is not trained. He is not being given that due respect or due importance at site, and the things happen the way that's not supposed to be happen. But that's the reality. We have to accept it. And if you see, the construction industry as a whole is the most labor intensive industry. It gives most of the hands a job, and that is the minimum need of any person, layman. अन्ना वस्त्र निवारा, एक घर के ऊपर छत होना, खाने के लिए खाना होना और कपड़े पहनने के लिए कपड़ा होना. This is the minimum need of any layman or any individual on this universe. But the ये जो है कि घर के ऊपर छत होना, वो छत की जब बात आती है, whenever that comes around us and that made of concrete, the most important person we give importance to cement, aggregate, this and that, but we lose focus on that person who is making the concrete. Okay, अच्छा material लाके, if you bring a good material at home, that doesn't give a guarantee of good quality of or tasty food. The same thing happens or applicable at site. Okay, if I bring a distillery water, basmati chawal or desi ghee, that doesn't mean I will get a tasty food. वो बनाने वाला अच्छा चाहिए. The maker should be a very good. So the same thing applied at the construction site. Even if you bring the good quality of material, that doesn't give a guarantee. But along with the good material, if maker is trained, properly trained, he knows how to do the job, then your ultimate product is not a cement or aggregate, ultimate product is a concrete. So if we look into that, that's a need of an hour, because in India, there is not a course or a training or institute or college or school wherein this training being imparted. Very less. Even if there are some ITI or colleges for mason training, but there are very less or few. How the mason becomes, he works under some trained mason and then he becomes the mason. Sometimes it may happen that what he is working under whom is not working properly, incorrect, improper. He will learn that and he will apply it to the next site. So that is going on at site. So paramount importance is, other than the quality of material, my humble request, how to train these laymen or these mysteries so that our work become easy. Because if you 24 hours you can't stand at the site, you have to depend on them. So unless and until they brought to the notice, if they make a small mistake, everything goes to the waste. So take an example of water. If they add 1 liter of water extra, I will show that example in my next slides. If they add 1 more liter of water extra of making a concrete, 1 or 1.5 megapascal strength of the concrete goes there itself. I repeat, if in a mixing of concrete, he add, because generally a water cement ratio should be 0.4, 0.45, max to max 0.5. But people are using 0.55, 0.6, 0.65, 0.62, means 45 to 35 to 45 liters of water in 1 bag of concrete they are using. So that should be around 26, 27, not more than 27 or 28, max to max. So 1 liter of additional of water is losing the strength of concrete by 1 megapascal or 1.5 megapascal. So how much it is important, we should understand, rather than advancement, rather than technological development, rather than challenge, the major challenge or skilled or trained labor. I think this is the need of an hour, rather than the technological changes that will happen altogether. And that is going on. All is going on. In Mumbai right now, if plastering is supposed to be done in a high-rise building, there is a machine which if you put the material in that machine, the plastering is being done faster than the labor in an accurate manner. But okay, that is one solution, mechanization. But is it only the mechanization will solve our problem? That's a question mark. So we have to look at all those parameters in a broader perspective as far as the construction industry is concerned. Now, why concrete is here to stay? Because concrete preserves. This is the biggest reservoir of USA. My earlier 2 speakers may vote for it. It preserves. Whatever if you made a dam, it preserves it. It is the biggest dam. It has built in 1931 and completed in 1936. This is the biggest reservoir dam in USA. So concrete preserves. So if it preserves, it is supposed to be stay, and it will stay for a longer time to come. Concrete soars high. Taken Burj Khalifa. This is around 830-meter high building, 162, 163 floors. So you can make wonders with the concrete. If you give respect, concrete will give respect back to you. Only the handling part, the respect part, the way you make it, it will last more than your expectation. And these are a few examples. So concrete is remain to stay here. Concrete connects. Whenever there is a problem or a river or anything, sea, anything, Bandra Worli ceiling, Bandra to Worli, we have built a bridge in a sea itself. So concrete connects, is a versatile material, cheapest material. It molds into any shape. So far, no scientists or scholars found the material like this. So the research is going on. I am again emphasis on that concrete is here to stay. Concrete withstands and sustains. Take an airport, runways, all those, whatever the load, impact, but it sustains, withstands any load. Or that's why I repeat, concrete is here to stay. Concrete gives a light to the life. Light at the end of the tunnel means if there is a very high hill or something in between, just my previous speaker told about the Lonavala and those Bombay-Pune Express Highway, there are so many tunnels that connect, that gives hope to the life. So concrete is here to stay. Concrete is a road to the prosperity. It gives a concrete road. initial cost of concrete road is high, but if you see the span of a concrete road, it surpassed the bitumen road. But yes, I agree, initial cost is on a certain higher side, but if you consider the life cycle of a concrete road, is really better than a bitumen road. Always repair. So many money, so many problems, so many things happen in a rainy season in Mumbai. Particularly, I face this problem a lot. So that's why concrete is a hope. Concrete is a solution. Concrete is an added advantage. So this is that is remain to stay here for a longer time. But the question what the student asks, is there any alternative that matters a lot? Hello? Hello?
Yes, sir.
आवाज आ रही है?
हाँ सर, आवाज आते हैं. Yes, sir.
मेरा आवाज आ रही है ना?
Yes, sir, आवाज आ रही है आपकी.
और स्क्रीन विजिबल है ना? क्योंकि मुझे थोड़ा ब्लैंक हो गया था स्क्रीन.
हाँ नहीं सर, वो थोड़ा ग्लिच आ गया था, बट अभी दिख रहा है सर.
अभी दिख रहा है. सॉरी.
नहीं सर.
So ये जो सवाल पूछा गया था student, the question being asked by that student that given me a insight that I should cover this point. That question was very important because he was asked a question that is there any alternative, because 92 to 93% of the raw material of the cement, or we can talk in concrete is made of 5 material, or 4 and 1 is a person or a human being. Fine aggregate, coarse aggregate, cement, water, and a human being or a mystery or a labor. Okay, all those 4 are a natural material, whether it is an aggregate, whether it is a sand, whether it is a water or cement, which has been manufactured. But the raw material for the cement, if you see, is the majorly is a limestone. 92 to 93% is a limestone. And this is a natural material which can be artificially can't be produced. And day by day, the ability of limestone or coal or gypsum or iron or depleting day by day, because this is a limited resource across world. I am talking about India. And whatever the screen you are seeing, these are the figures not by UltraTech but by Indian Bureau of Mines 2013 and 14. Before going ahead, I will tell right now the Indian cement production capacity, installed capacity is around 430 to 440 million tons per annum. I repeat, the Indian installed cement production capacity is around 430 to 440 million tons per annum. If you consider the population of India is around 130 to 132 crores. If you divide this, the per capita consumption of cement average of India is around 300 to 310 kilogram per person. As far as the world population is concerned, world population is hello.
Yes, sir.
Audible? My
yes,
screen.
You're audible.
Yes, sir.
My screen is there, na?
Yes, sir.
Yes.
Hello.
Yes, sir.
My screen, because I am not seeing my screen, that's why I am asking again and again.
Sir, it is visible. Your screen is visible.
Hello.
Hello. Sir, your screen is visible, sir.
Sir, your screen is visible, sir. Hello, Hemant sir.
I guess there is some connectivity issue.
Yeah, hello.
Yeah, hello sir.
Hello. आवाज आ रही है?
Yes sir. Yes sir. Audible sir. Yes, it is also visible sir.
Hello.
Yes, sir. You're audible.
Hello.
I guess sir can't hear us.
Hello.
Yes, sir. Hello.
Now audible?
Yes, sir. You're audible now.
Sorry, yaar, this net connectivity is creating a problem for me.
No,
Now
sir.
screen is visible.
Yes, sir. It's visible.
Just a minute. Okay now.
Yes, sir.
Yes, sir.
Sorry for this inconvenience. So I'm talking as far as the world is concerned. So if you divide the world population with the cement production in the world per capita average cement consumption is coming around 430 to 450 kilogram per person. As far as the China is concerned alone, China and India, and China's per capita cement consumption is coming around 2000 kilogram per person. So if India has to become a superpower, infrastructure, road, bridge, dams, everything has to come. But whether the cement production is to be increased, if cement production is to be increased, then whether the resources are available. So this is the question which is to be answered, and very paramount and very important question, because day by day these resources are going depleting. So scientists and scholars and concrete technologists are working on this. So we have to use the optimum cement for a better results. Now people have gone to 80, 100 megapascal, 150 megapascal. In America, one has gone up to 300 megapascal strength of the concrete, and he has made a car out of it. So people are working on it. Now there are 5 supplementary material being introduced, and we are using it. One maybe it is fly ash, GGBS, metacholine, or silica fumes, or rice husk. So efforts are going on how to reduce the limestone content, so that life of the limestone ability or life of the cement increases iron ore. So if you use that way, only 110 years are there, we can able to produce the iron steel or iron particularly. If you see the lifespan or index, and if the quantity or production increases, this may come further down. So we have to use this precious material very judiciously. The best part, we have to find a supplement or alternatives for these materials. But so far, working is going on, research is going on, things are moving ahead. But so far, there is not an alternative to cement or concrete as far as the construction industry is concerned. Now, what are the important steps wherein we generally make the mistake, or which are the very paramount of importance you learn in your concrete technology, in your curriculum? But even though I want to make it very clear that these are the steps, whether it is a batching, whether it is a mixing, whether it is a transportation of that material, whether it is a placing of the concrete, whether compacting of concrete. whether finishing of concrete or taking care of curing of concrete. Each steps is very important. Any mistake in any one step, if you make, you will get the symptoms. And what is that symptoms? That symptoms is cracks. Cracks is not a disease, but it is a symptoms that you are made some mistake, either batching, mixing, transporting, placing, compacting, finishing, and curing. And before batching, selection of the material. One important, I missed a selection of material, batching, mixing, transporting, placing, compacting, finishing, curing. Each step has its own importance, and due care to be given to each these steps to avoid the major disease, or not disease, or symptoms of a concrete, which is well known by everybody, and that is cracks. Crack doesn't happen by its own. If you do anything with this, that will automatically come. If any consultant or any engineer or any builder or any contractor or any mason says, whatever the concrete I will make or place, there will not be a concrete to the 0.1%, that he's speaking wrong, because क्रैक may come or may not come. जैसा कोई इंसान बोलेगा कि बचपन से लेके बुढ़ापे तक मुझे बुखार ही नहीं आएगा, फीवर ही नहीं आएगा, ऐसा बोल नहीं सकते हैं. सेम थिंग विद द क्रैक्स. So if we take a proper care of all these steps, there are 99.9% chances that a crack fix, a dense, a strong concrete will be produced. And one of the problem what I observed during my tenure in a cement industry, whether it is a qualified engineer or an experienced contractor, they measure due force or trust or importance to the strength. Okay, strength is the only criteria to be considered. That's a question mark. Because we are talking a new age of concrete. We are talking various form of concrete, high strength concrete, high performance concrete, self-compacting concrete, so many and so forth. So the engineers, the student, who are coming out of the colleges or campuses, I am sorry to say, when I visit to the engineer or contractor some site, some of the engineers say, no, sir, for concreting or for slab, PPC cement should not be used. वो राख वाला सीमेंट है. If an engineer say like this, that hurts a lot. राख वाला, is it a rock? Is it a ash? A cement industry is mixing in a cement. Is it a ash? They should know this is a fly ash, a finer material than cement, which contain a silica. That is known as fly ash, which is being added to improve a certain properties of concrete, which can't be used. Take an example of your gold. By 24 carat, whether you are making any ornament, whether it is a chain or anything, any gold ornament, with 24 carat of gold, you can't make any ornament. That is as good as you keep in locker or in bank to get a value for it. But if you want to make any ornament, you have to mix something which is known as copper, and copper being added to change or to improve certain properties which a pure gold doesn't possess. That way, OPC cement, yes, that is a good one. 33, 43, 53. But OPC cement itself has some deficiencies. To rectify, to remove, to improve certain properties of a cement or concrete, or fly ash or GGBS or metacolin, these are being added at a plant level. In a RMC plant where they have a proper control of mixing, they add separately. They buy OPC cement, and depending on their control, they add fly ash or GGBS or whatever the material available, they add accordingly. So any graduate engineer or anybody coming out of the campus should know what is PPC, what is PSC, what is OPC, what is 43, what is 53, where to be used, why not to be used, before, because cement was decontrolled in 1981-82. Before that, cement was not been graded. Cement we've been purchased and sold as a cement. There was not a grade of cement, not on 33, not on 43, not on 53. That time, Taj Mahal, Qutub Minar were built. That time was not on 43 and 53. Even they are standing right now. We are going along with our family and visiting those places. That time, whether 43 or 53 was there? No. So these are the simple questions an engineer before leaving the campus should ask himself and to get it clarified. What is that? How it come 43, 53, what it means, why it come. So unless and until you ask your question and get it clarified within the campus itself, it will be better to go into the market, because industry is not looking into how much percentage on how much knowledge, book knowledge you have, but they see how you implement it. What is, how, whether you know it in a principally. So you should know, you should ask a why question to yourself, why this? And then it makes sense, rather than just mugging it and reproducing during the exam will not get any result or fruit in the marketplace. So these are the very small things which I am showing. You might be thinking why I am showing this. You read all this, you know all these things. But even though I am showing this, because these are the very important steps, wherein as an engineer, we doesn't take care. We only go during the slab casting. We stand in the morning, after evening, afternoon, when the slab over, we come back. We show to the owner, to the engineer, to the everybody that, yes, I was there. But what you are done standing there? What the value addition you are done, my dear? Nothing. You stand only putting a cap on the head. Yes, I am there. So this will not work in a long run unless and until you understand a cement and concrete. This is a bread and butter, particularly for civil engineer. So concrete look very simple. But even after spending 26 years in a cement industry, working in a various department, I don't know about concrete anything. So whenever you mix it, you meet with the concrete, you will find something different. So always you learn something new. So people even spend 30, 35, 40 years in a concrete technologies, even they know 100% of cement and concrete. So this is a very versatile material. We can't claim we know 100%. So there are a lot of scope to understand, to know of concrete. It is not only a mixture. It's a very different material altogether to understand. Now, these are the two pillars of concrete, strength and durability. Just briefed before, generally people or layman or engineer or architect give more importance to the strength, but now the era along with the strength is not only of the strength, but of the durability, which is of paramount of importance. In an Bandra Worli ceiling project, along with they are given a same weightage to the durability, because that structure to be strong, wet and drying. So durability plays a major role in some structure, whether it is tunnel, high-rise building, or structure in a sea, or important structures. So give a proper thought to durability. Only strength doesn't surpass, or only the strength is not the criteria for your structure or analysis. So durability should be given a paramount importance and days to come if you want to preserve this real. Sorry to say, whatever cement produced in India, what I spoke previously, 430 to 440 million tons per annum, sorry to say, around 27% of this material, cement itself, goes for repairs and rehabilitations. I repeat, around 27% of the cement is going to repairs and rehabilitation. The building is supposed to stand for 100 years, wants repairing 7 years, 8 years, 10 years, 15 years, 20 years, 25 years, not more than that. What is happening? As we are growing, we are saying there is development, innovation. Everything is there. But if the Qutub Minar is standing since so many years, Taj Mahal is standing in so many years, and our own Taj Mahal, which we built, is not standing for 8 to 10 years. That demand a repairs. But there are a paramount important pillar, which is known as, I repeat, durability. Now, what is durability? Durability of concrete is the ability of the material and the structure to maintain its level of reliability, of serviceability during its lifetime with the normal maintenance cost level. It should be maintained as it is. Its reliability, suppose you design for 100 years, at least that structure should withstand for 100 years with the minimum maintenance. That's a durability. Now, factors which influence durability, which you know all, you are gone through IS codes and everything. I'm just running through the environment, type and quality of constituent material. The most important in all of this is water cement ratio, and where we make a blunder. What we learn in college and what really happened at site, if you see, you will not stand there for a few seconds. While talking about this water cement ratio, during your academics, you learn consistency. Any test on cement and concrete, you have to calculate, or you have to know a consistency. How much consistency percentage? Okay. So if you calculate consistency, you add certain water, and that is in liters. But at sites, they put a pipe of water while mixing the concrete. Even concrete stands. So there is a wonder of this material. Because in a ml, water cement ratio is always in point. 0.4, if you get an answer of 0.41, your professor give you a 0 mark. And at site, what happens? Not an ml, they add in liters. Even the things are going on. Nobody is worried. We are not worried about that. So many things what we learn academically and what actually practically happen at site, we have to balance it. And that's the typical thing. And that's why most of the thing I say, civil engineer is not a rocket science. In a previous lecture to your college, I use that word. Civil engineering and rocket science. It would have been a rocket science. The Angtha Bahadur would not be become a contractor, or today you would not have been a more job than us. We have a qualified diploma, degree, or doctorate, everything. But even Angtha Bahadur is a contractor, and he has got a more job or more work than us. It proves that civil engineer is not a rocket science. If an Angtha Bahadur can do any contractor, any building, how you can term is a rocket science or a technology. So there should be a difference between a qualified engineer and an Angtha Bahadur, and that's the matter of the crux in today's presentation, because subject is future challenges. Future challenges to retain this work with the qualified engineers who are better what is expected by the society, and this expectation will be fulfilled only unless and until my civil engineer who are getting out of the campus, who are confident, know the subject well, they know the why and how to do the things, then and then the respect for the civil engineer will increase. Because sorry to say, civil engineer is the lowest self-esteem person in today's scenario in the marketplace. Sorry to say. Because suppose I am a civil engineer, I am working in UltraTech, I am a regional head, and one of diploma holder is working under my, if I doesn't give a respect, being a civil engineer, the society will not give a respect to that person. And in today's scenario, self-esteem of a civil engineer is at very low level. We have to work upon it, how to improve the self-esteem of a civil engineer, so that whatever the time, the precious time, the money he's spending learning, that will be respected by the society at large. So this is in our hand. We together can do this wonders, and to the nation and universe and to this planet a great service. If we do a proper, for the sake of qualification, don't do it. You should be educated rather than qualified. So rather than a degree, an engineer degree, or just for the sake of B, don't take it. You should be educated rather than qualified. So most of the contractor are educated, they know their job well rather than qualified. And most of the engineer qualified, but they don't know their job. And this is the reality of ground reality of. Hello?
Yes, sir, you're audible now. Yeah.
Yes.
Audible, na?
Yes.
Screen is visible?
Yes, sir, it is visible.
Okay. Because I'm not seeing my screen myself. So there is some problem. Just a minute. Just a minute. Just a minute. Hello? Hello?
Yes, sir. You're
Audible,
audible.
sir?
Yes, sir.
Yes. Screen is okay?
Yes, sir. Screen is also okay.
Okay. So these are the exposure conditions which you learned, you know everything. Just for the sake of durability, I'm just taking it to in a fast pace. You all know, you learn this, but these are very important, not to be taken lightly. IS 456 is Bible to us, or Quran or Gita, whatever you name it. These are the minimum cement content and grade of concrete cover and maximum water cement ratio. Why I am showing this? If you see the maximum free water cement ratio in PCC and RCC, it is not going above 0.55, even in a mile. If somebody asks me what is the maximum water cement ratio for a cement paste or hydration, I will say 0.4. Even 0.4 is on a higher side. For a cement hydration or reaction only require 0.27, and this remaining 0.13 is being utilized by the concrete itself for years for developing the strength. If you see the concrete after 28 days, concrete gain the strength after 1 month, 2 months, in a year. In a year time, concrete get more strength. So how it gets strength if free water is not available within the concrete? So particularly if somebody asks me, hydration, for an hydration only 0.7% water is required. The balance 13% water within the concrete, even from outside, if we see hardened, the 0.13 remains within the structure of the concrete, and that is being used for developing the strength for a number of months and years to come. So why I'm showing this slide is particularly will be explaining to the next slide. Not this, this slide. So what we do for M20, because at most of the site, volume measurement being used to make the concrete, and these gamelas being used for making the concrete, and these gamelas are the most difficult thing. These gamelas is creating jamelas, most of the jamelas of the concrete. One bag of cement, somebody use 10 gamelas, 12 gamelas for sand, 12 to 15 gamelas of aggregate. Water cement, they never measure. They take the hoist of the pipe and they throw the water. Sometimes by a bucket, sometimes by that horse pipe or whatever the means they use. Sometimes they use the quality of water. I'm not here to talk about this. Somebody use that bore water, somebody use river water, somebody use municipal water, somebody may use gutter water, whatever the quantity, gamelas, and then the finger point to the quality of the concrete, and at the end finger point to the cement, because he is the only person available to answer. Because where to find that sand supplier, where to find that aggregate supplier, where to find that water supplier. That Mr. is a human being, and tendency of human being never to accept our mistake. So who remains? Only cement manufacturer. Pick up his collar and ask him, your cement is wrong. So these are the always going at the side. And if you see this calculation, so average weight of one gamela sand is 15 to 18 kg, means we are mixing around 150 kg of sand in one bag of cement concrete. If you take an average same 15 to 16 to 18 kg of weight of one gamela aggregate, that again come to 180 kg of sand and 180 kg of aggregate and sand. If you total it, that average weight of aggregate, fine and coarse, is coming to, which is much higher than upper limit prescribed for nominal mix it 250 kg. I will show to the IS code page. See, in IS code, we teach this thing to the student in the college. For the sake of academic, they only learn, put as it is in their question answer in a final exam. They pass, they come to the side, and they do the way the things are happening. How the things may change. Unless and until individual change, we change our level, the change will not going to happen. And that's why I'm repeating this. We learn this thoroughly in the college academics. If you see, the maximum weight should be 250 kg and water per one bag 30 liters. So if you go to the back slide, water cement ratio 0.7, 0.9, and the total weight of the fine and coarse aggregate is coming to this is minimum I am talking to you. So these are the things which are going happening at site. Now, concrete is no exception to the human system in life. Generally, I explain concrete in a simple way. Instead of reading so many books, so many things in library, in academic, if you understand human being properly, you understand concrete properly. No, not need to read so many books and so many things and so many years of experience. If you understand human being, because concrete behaves as human behaves. Concrete act as human acts. And that's why if you take example, in a childhood, whatever the good food or good thing you give to the child, the child will become healthy and everything. The same thing for the concrete. What is the ingredient you select, the concrete will become that way. The culture, the values in the early age, in our childhood, you give to your child the value, the principle, the culture. In an early age, he take the shape of that. The same thing happen with the concrete. When it is in plastic stage, whatever the shape, change, whatever the thing you handle, place, curing, in an early age, shape, everything, that will be in his lifetime. Now, as the child's age increases, 1 month child, 3 month child, 6 month child, 1 year child, 2 year child, 5 year child, 15 years, as the age increases, his mental and physical strength increases. Same with the concrete. 1 day concrete, 3 day concrete, 7 day concrete, 28 days concrete, 1 month concrete, 1 year concrete. As the age increases, concrete strength and everything increases. As the child become adult and he run on his 2 legs, the same thing happen with the concrete. Concrete always run or goes in a service span life on a two legs, strength and durability. If strength is there, durability is not there, he will not go in a longer line. Durability is there, strength is not go there, concrete will not survive for a longer life. The same thing. As the person or human being being term lifespan 100 years, concrete is also designed for 100 years. So same thing. If anything bad or any small or big illness happen to the human being, a symptoms being a fever. If fever is not rectified 1 or 2 or 3 days, we go to the doctor. Doctor asks the first question, from how many days you are getting fever. If we say 3 days, doctor says to us, kindly check your blood, come back to us with your report, blood report. Then that they detected which is there any problem or this a normal fever. The same thing. If you do something wrong, selection of material, batching of material, mixing of material, placing of material, transportation of material, taking care of material, curing. If you make any mistake, that's so one sentence, and that is a crack. In human, there is a fever. In concrete, there is a crack. Crack is not a disease of concrete, but it is a symptoms of concrete. So a person who knows human behavior in a better way will correlate with the concrete, and he will deal in the way it's expected to be dealt with. We are not dealing in a child. We are not putting our child and throw our child on a bed, but we are putting that concrete in a mason's head to he's throwing that concrete, but we are standing on a slab and we're putting our hand folded. Yes, we are standing on the slab. What we are doing there, standing on a slab casting? And is it required to stand on a slab casting day? Whether a slab is carrying any strength? No. The column and beams are carrying strength. They are the most important foundation, column and beam, but no engineer is standing, visiting, supervising, but he stand on the slab casting day. These are the finer things as a real civil engineer to understand where to the importance to be given, what to be checked. I am supposed to be civil engineer only to become a civil engineer, to be know how to construct a house or building or road. Now a normal layman from Google, anything, they are more knowledgeable than us. So update ourselves, be vigilant, be a master of your subject rather than just knowing hypothetical things. So these are the things. Now handle a concrete with care, utmost care. Don't take that material very lightly. It looks like it looks very casual material, concrete, but it's your image, your everything depends on the concrete. So I request, don't take that material as light as you are thinking of. Now, as far as the today's subject is concerned, evolution of construction industry. Yes, there is a lot of evolution from material, from machineries to the construction methodology. Take the example of construction. Previously, the houses were mud, then stone, then wood, then load bearing, to RCC, to pre-stressed. Take kind of machinery, hand mix of material, then site mix, then machine mix, then RMC, then pre-stress. So lot of changes evolution is happening into the construction industry as such. So RMC is one of the part. Lot of type of high strength concrete, self-compacting concrete, pervious concrete, decorative concrete, jeep concrete. Now concrete available just like your pizza is available, instant concrete. Because suppose I am having only one spot where that concrete is spoiled, so I am not going to bring cement, sand, and that mixing at site. There is a restriction in my society, so I can't do that. So if you order a 25, 5, 10 kg, that material is available in a bucket. You have to bring that 5 kg, 10 kg, 25 kg in a bucket. You have to pour that concrete, just rub it, and within a hour, your that small repair work can be done. So that is now available, just like a pizza and instant food is available. So now the life or civil engineering also become instant. So lot of material is available, lot of things are changing. So you have to upgrade the latest technology, material, procedure, infrastructure, development. So lot of changes happening right now in a construction industry at site itself, and in a R&D center. It's also lot of ready-made material, plaster material, ready to plaster material. You have to bring the material, only add water and just do the plastering. So lot of material, previously mud bricks were used, then cement concrete bricks were there, then fly ash bricks. Now they're AAC block, autoclave AAC block bricks are there. So lot of in material itself, construction methodology per se going on, and people are exploring lot of things in day-to-day life. As far as advantage of RMC is concerned, UNIMC is there. We are providing for ISB and small workers. So do use if there is any restriction, or you want consistent quality, or time is the constraint, or quality is the constraint, or you want ensure the quality. So I will recommend go for an RMC per se. Now, as far as the UltraTech RMC various kinds, due to time constraint, I will cover 3-4 only. But number of new added advantages concrete we are producing. And for the sake of showing this presentation, I'm not showing. We are around 6 to 7 RMC in Pune and PCMC. So we are producing all this RMC what right now I'm showing to you. So I request you to use this, recommend this, RMC added advantage, RMC or value added RMC. This UltraTech Concrete Plus. This RMC we recommend for high early strength, or there is a problem with the slump retention. So on those places wherein high early strength and slump retention or slump is a criteria, wherein we recommend or we supply this Concrete Plus Concrete Plus RMC, ready-made RMC, those side. So this is one development. Then again, pervious concrete we supply, because this is the concrete pervious. Generally, being a civil engineer, we have been advised, we have been trained how to avoid the leakage, how to make a waterproof concrete. But this is the concrete which give in depth or through water through pass through the concrete. This is a totally a reverse kind of concrete, wherein we prepare a concrete precisely designed with optimum paste of cement. We prepare this kind of concrete, and this is being supplied to the park or in pathways or some part of the colonies road. Because whenever they in a rainy season, what happens in Mumbai, Chennai, Pune, in a rainy season, when if the water flow increases, that water got stacked, and we are faced in Mumbai also 8 to 10 years before, wherein we lost around 8 to 10,000 lives when water flooded like anything, and there was no way for a passage of that flood water. So due to concreting or concrete jungle. So what now the BMC or Chennai Municipal Corporation or Pune, what they are doing, at least a park or deck of swimming pool or pathways or side track of the cycle track of those side of the colonies, and those are being made with this pervious concrete. So what happens whenever water in a rainy season water falls, this water seeps through this concrete. So there are two advantages. One, there is not flooding. Second, the water, this water, flooded water is not flowing away, but that is going seeping through this pathways and this roadways. So water goes through seep through these pathways and paths, wherein the water table of that area increases, which can be used later on in summer season. So we are avoiding the flooding of the area also. At the same time, we are increasing the water table of the nearby our locality or of that area. So such type of product now being promoted, being made and being supplied. Now, UltraTech Hypercon, wherein if the slender structure, whether it's a column or beam, is to be made and high strength is required, wherein this type of concrete being supplied and produced hypercon using various material, wherein M60, M80, M100 material can be produced and supplied, wherein slender, pre-trace or in situ material, concrete or material or member can be produced and can be even pre-traced or made at factory and can be supplied, wherein we supply hypercon concrete. Then again, we produce and supply stainless concrete. Majorly, this concrete is nothing but the coating of the reinforcement to not to get corroded in a water-prone area or coastal area. So, water water tank or swimming pools, wherein this particular type of concrete being produced and supplied, and we are supplying this in Pune also. Concrete decor, wherein color concrete, wherein using world-class UV resistant color hardener, which refrains the true shades of the color for a longer duration. These are added, pigment being added, and the shade, the design, whatever the type of color, design, shade, what you want can be produced, can be supplied, and can be placed at your side. So lot of development and things are happening and being made in a construction industry. So evolution, as far as the evolution is concerned, so lot of evolution as far as the material is concerned, as far as the construction industry, either equipment is concerned, material is concerned, or construction practices is concerned, that is happening, going on. Lot of changes in the coming days is happening. Now, as far as the material in a cement, there are a lot of changes is happening with weather plus we are brought weather plus cement, which cement, if you use, repel the water in a rainy season. If you use that cement in a concreting in a slab, that itself repel the water, so that water doesn't seep in, so your leakages and all those problems can be avoided. So lot of development is going on as far as the material, as far as the equipment, or as far as the construction practices. But sorry to say, lot of things to be done as far as the good construction practices is concerned, because right now also at a site level, the things are not doing as expected. Things are doing in a very haphazard way, or the way it is not expected. Lot of precious material like cement being wasted. That cement waste is not a waste for that individual only, but that's a waste of a nation property, national property. So that's a national loss. So a lot of care to be taken, because as far as the cement is concerned, people only look as the cost per bag, but they are not going to the detail to what it is to be looked into. So these are the various parameters, where various things, where in today's scenario, our young engineer, budding engineer, to be looked up to, we are looking toward them as the pioneer in as far as the material is concerned, as far as the this construction practices or good construction practices or infrastructure or whatever the infrastructure require or material require or other things, we are looking up to those from budding engineers. So my best of wishes to all the budding engineer. The industry is ready to take you on their shoulders, provided you contribute to the industry in a better sense, in a longer sense, and as far as the industry is concerned, civil engineering is concerned, or as far as the profession is concerned, a lot of expectation are there from the new budding engineers. So I hope and I wish and I am sure this team of new budding engineers will definitely will change the scenario altogether. Thank you, madam, from my side.
Thank you so much, sir. It was a great presentation and very informative session. We have some questions in the chat box, sir. I'll just read it out to you. Sir, the first question is, in earlier days of construction, the construction was done with lime only. As per durability aspects, those structures are still safe or remain stable. Please convey your opinion and valuable reason. Oh.
Yeah. Excellent question. You are correct. You are 100% because Qutub Minar and these all those previous, or you can take the pyramid of Egypt or Great Wall of China, all those things. That time only the lime being used. But yes, lime being used that time, no admixture being added, not so sophisticated or 53 or 43 grade of cement was there. But one thing was there, the skill labor, the way they have used that way. And second thing, this lime, they have used and mixed and they are prepared in a way that is more consistent. Now the cement what you are getting in the market is today you are getting 43 strength, tomorrow the same batch you may get something else strength. The quality of cement is not consistent what you are getting right now into the market. Second, previously they use some form of plasticizer, which is a natural one. Whether it is they also use some fibers also, which is that hair of horse or hair of bullock or those hairs in cutting form as a fiber reinforcement they have used in their structures. Some type of blood, animal blood also they have used. I am not saying that we have to use right now, but they use those kind of things in their construction. So till date they are sustained, they are there as long as strong as even today's construction are there. Even they are not requiring the repairing for that matter. So I think those are the things which made them very strong and durable. But in detail, still I am in a search why they are still strong and durable and why not in today's scenario. But if you see the M100, M80 strength of structure, whether it's a Delhi Metro or Bandra Worli ceiling, they are made M80, M100. So I think they will last more than 100 years. Because they are designed more than 200 years, because these are structure which can't be made again and again. So now the thrust is more on durability rather than the strength. In the last 2 decades, the thrust was more on strength, not on durability. In last 2-3 decades, and that's why the problem majorly we are facing. I think I close to the answer.
Yes, sir. So the second question is, can we use GGBS as alternative to fly ash in RMC? If yes, then what percentage should be used? And also, what are the advantages and disadvantages of GGBS in RMC other than fly ash?
Okay. as far as the GGBS and fly ash is concerned, both are supplementary cementitious products. There are 5, but abundantly in a thermal power plant, a good quality of fly ash is also available, and in a iron or a steel plant, this GGBS is available. Now, as per IS code, fly ash is 15 to 35% you can add with a better control. And in RMCS, there are their own labs, and they are mixing in a controlled way. But for a layman at site, it's not possible, and that's why we recommend a ready-made PPC or PSC cement. This is as per as the fly ash is concerned. As far as the GGBS is concerned, yes, the percentage is ranging from 25 to 65 to 70 now. Code recommend 70% now, even above if the quality of GGBS is good. So the percentage varies because in a GGBS, the percentage of silica is more than in fly ash. And in limestone, if you see the major contribution of the strain or your hydrophobic reaction or C3S or C2S or C3A, this compound making the silica is the major component which gives strength to the ultimate product. So in a GGBS, the percentage of silica is in a good percentage as compared to fly ash. So we generally recommend GGBS, but a good quality of GGBS is not available, and if available, that is costly than the fly ash. So the RMC are a commercial ventures, so they go for fly ash. And for that matter, I can say even silica fumes gives, if you want to go for M100, M20, M80, you have to go for silica fumes. So, but silica fume is more costly than fly ash and GGBS. So, depending on these are all RMC plants, even mine or others, or are commercially RMC plant. So, we weigh on the all these financial aspects, and then we go whether to go for a fly ash or whether to go for a GGBS or whether to go for a silica fumes or decocholine or rice ash is not being used, but that is also recommended as a cementitious product. So these are the things which are considered in a commercial RMC plant. Yes, sir.
Okay, thank you, sir. So those were the questions. So I now request
Thank you, sir.
to everyone to please turn on your videos. We'll just take a photograph of the session. Everyone, please turn on your videos.
Sorry, sir, my range, my connectivity is low.
No, okay, sir. Okay, sir. No issues. No issues. So please, can you just end the screen share of the PPT?
Yeah. Is it okay now?
Yes, sir. Yes, sir. Participants, please turn on your videos. Okay, thank you so much. I now request Preeti ma'am to continue the session.
Thank you, sir, for an excellent presentation and giving us so much information, and also for addressing the question of our audience. So all participants are informed that the feedback link is available in the chat box and the YouTube channel. Kindly provide us with your valuable feedback. So today was indeed a great day of knowledge sharing. I now wish to take this opportunity to brief the session of today. During the first session, Mr. Josh Kistner highlighted on topic infrastructure construction. Josh gave us comparative details of infrastructure contracts sectors in USA and India. He shared example of different field under infrastructure construction. He enlightened us on different techniques used during construction of bridges and highways, including foundation, bridge steel, concrete, and earthwork aggregates. Mr. Joss explained the necessity, function, and the technologies used with the apt photograph and case studies. During the second session, highlighting the case studies on construction engineering, Tejas Borse has explained highway infrastructure in detail, but also explained the growth of redevelopment of infrastructure project and related aspect. He has thoroughly explained the life cycle of an infrastructure project and its different parameters. Tejas also focused on the possible scope of extension, redevelopment, and sustainable solutions for existing infrastructure projects. During third session, Engineer Hemant Jain enlightened us on the future concrete. He enlightened us about the heritage, expanse of UltraTech Cement Limited, importance of concrete, and the fact does not receive its due importance, but actually has provided not only strong and sturdy infrastructure, but also has provided various employment opportunities. He touched on properties of concrete, such as soaring high in tall structure, withstanding loads in dam structure, or becoming a road prosperity. So, Sirs rightly said, concrete is definitely here to stay. He highlight the concrete as a precious material which we should use judiciously. The lack of workmanship of which shows as a symptoms in the form of cracking. The importance of water cement ratio and good construction practice for establishment of strength within the structures built in situ. Okay. So I now I invite Dr. U.R. Avari, HOD Civil Engineering Department, to present the vote of thanks. Over to you, sir.
Okay, thank you. Am I audible?
Yes, you're audible.
Okay. I, Dr. Uttam Avari, would like to extend my gratitude to the speaker of today's International FDP, Mr. Josh Eastern, Tejas Borse from the Superior Construction, Indiana, USA, and Engineer Hemant Joshi, Regional Head Technical Services, UltraTech Cement Limited, Pune, for sharing their vast knowledge and providing us with such valuable information. I am very much thankful to the member of management of AISSMS College of Engineering for their encouragement, our principal, Dr. D.S. Bormane, for its inspiration, and the head of the other department of AISSMS COE for their support. I extend my gratitude to Mr. Harsh Ashok and Silpi Madam, convener of the today's FDP, all organizing team members for their tireless effort, the media team for hosting the session so smoothly. I also extend my special gratitude to you, respected audience, for participating in this FDP. Now I declare the session is over. Thank you.
Thank you.
Thank you so much, sir.
Thank you.
Vedant?
Yeah, thank you, Josh, sir. Thank you, Tejas, sir. Thank you, Harsh, sir, for joining. And it was a really great session. All the sessions were great today. Yeah, thank you, everyone.
All right, then see you next time.
Yeah.
Bye-bye.
Yes, thank you, everyone.
Yeah, thank you.
Tejas is there? Tejas? Hello?
Sir, I think Tejas sir just left the meeting.
Okay.